Very good morning, all. Let us start. Next, we are going to discuss about three-phase full-wave rectifier, right? So already we have been discussed about three-phase half-wave rectifier, right? So we saw how to calculate V naught average, right? And I told you in the same way we can also calculate V naught RMS, right? And we can also calculate the value of thyristor average current and RMS value of thyristor current. I am requesting all, please calculate the average value of the thyristor current and RMS value of the thyristor current after at the end of these three phase full wave rectifier. Here I will solve, right? From the same way, right? After seeing the procedure that I am giving here, in the same way you can also solve that one, right? Okay, let us start. So next we are going to discuss about three phase full wave rectifier, right? Once again, if you want to design three-phase full wave rectifier, right? In the sense we are going to control full wave, right? And in three phase, and we are in star connected system. That things we know. In star connected system, the difference between line voltage and phase voltage also we know, right? Your line voltage always leads the phase voltage by an amount of 30 degree. That things we know, right? Second, what we have understood, each and every voltages. In case of phase or line, it does not matter. They will have 120 degree phase displacement in case of three phase system. That things are to be understood, right? Yes, let us go ahead. Next, apart from that, there are few more things to do. So when we are looking for three phase fully controlled rectifier, that is full wave rectifier, we are requiring, that is here I am making of 6 switches. We are going to utilize 3 switches effectively in order to design three phase full control, that is full converter, right? So for 6 switches in the sense, what about the firing angle period? First, let me draw the circuit. Let us demonstrate all the things, right? Now, once again, let us draw the three-phase full wave converter, right? Full wave in the sense we are going to use effectively 6 switches, right? Totally, we are going to use 6 switches. The number of switches are going to be 6. Then, how many pulses we are going to generate? We are going to generate 6 pulses, right? Whereas in case of three-phase half-wave controlled rectifier, we saw we had generated only 3 pulses, but now we can generate 6 pulses, such that our rectification efficiency of the system will be improved a lot, right? Yes. Now this is the point where we are going to connect our loads and all, right? Okay. Now in this three-phase configuration, first thing, let us see. 3 phases are there, right? So this is phase A, will going to be connected to this one. Phase B is connected to phase B supply. Phase C is going to be connected to phase C supply, right? So that is phase A, phase B, phase C, right? Now, if you observe in the mid of the leg, how many legs are there? Totally, these are called limbs or legs. Totally, we have 3 legs, right? Midpoint of the leg, in leg number 1, midpoint of the leg is connected to the supply. In the leg number 2, midpoint of the leg is connected to the supply. Even in leg number 3 also, midpoint of the leg is connected to the supply. In the sense, in each and every leg, right? In each and every leg, from the supply, if you observe, there are 2 switches. One switch will be placed at the top of the supply, another switch will be placed at the bottom of the supply. If you observe, right? So in phase B also, above phase B we have a switch. Below phase B we have one more switch. In phase C, above phase C we have a switch, below phase C we have a switch, right? But here we are effectively using controlled rectifiers, right? Controlled rectifiers in the sense they are called what? SCR, silicon controlled rectifiers. And in the upper leg, I hope you all remember, when I had given the introduction for these rectifier circuits, I told you in the upper leg we are always keeping odd number of switches, right? Let us see, T1, T3, T5. These are the switches that we are going to consider in the upper leg. Whereas in the lower leg, we are going to consider even number of switches they are being named as T2, T6, T4. Sir, why these two people have been interchangeable? The thing is, in order to get the switching sequence in the sense, in our supply, usually in three-phase system, first T6 and T1 will turn on. In each and every time period, one pair of switches will going to give its contribution. We have seen already in single phase rectifier also. When I was discussing about half wave rectifier, I took only one switch. But when I was discussing about the full wave rectifier, I took 4 switches. Out of those 4 switches, 2 switches are going to be contributed with what? One cycle, right? That is for one pulse we took 2 switches. In the same way, in 6 pulse converter also we are going to take, right? We are going to take 2 switches in order to contribute with one pulse, right? Let us see. So that is T6 and T1, and next first T6 T1 will contribute, and then let us observe the sequence. T1 T2 will contribute, and then T2 T3 will contribute, and then T3 T4 will contribute, and then T5 T6 will contribute. Again you are getting the same cycle, T6 T1. This cycle is being repeated. Clear? This is the switching sequence. In order to get this type of, right, switching sequence, right, I am in need of successive switching sequence, right? In order to get the consecutive, right, switching sequence, we are trying to go with these type of arrangements. And the next thing is, upper legs will always deals with the positive voltage, and lower leg deals with the negative voltage. Right? Now we all know, if you want to turn on the SCR, then we have to satisfy 2 conditions. Condition number 1 is, the injected voltage across the anode should become greater than the value of the voltage across the cathode, and the second one is, the injected voltage across the second one is what? The gate bus must be not equal to 0, right? If you are satisfying these 2 conditions, immediately your circuit will turn on. So since we are in 3-phase fully rectifier, now this is our circuit. Later we will discuss about the nature of the loads and all. Right now, how many switches we are going to consider? Totally 6 switches. Right? Now, 6 switches in the sense we are going to generate 6 pulses. So the thing is, firing angle of the circuit is depending on, let us see. Firing angle, or we can say firing angle in the sense, in between 2 switches, right? What will be the phase angle difference? At which phase angle difference we are going to consecutively fire the switches, right? In order to know the firing period of a switches, right? So in between thyristor T1 and T2, what will be the firing period? For thyristor T1 வந்து at 10 degree நீங்க ட்ரிகர் பண்றீங்க அப்படினா, for after how many degree, right, we are going to trigger T2, and for after how many degree we are going to trigger T3, T4, like that we have to know that one, right? So that can be divided by 360 degree divided by number of pulses. Anyway, we are going to generate 6 pulses now. So it is going to be what? 60 degree. In the sense, if I have triggered the thyristor T1 at 30 degree, T2 will going to be triggered at 30 plus 60. We have to wait for next 60 degree. At 90 degree, T2 will be triggered. From 90, next 60. 60 plus 90 will become 150. At 150, T3 will be triggered. From T3 again, after 60. At 210, T4 will be triggered. After 60, that is 270, T5 will going to be triggered. And then at 360, T6 will going to be triggered. And the sequence is being repeated. Clear? So that is how we are finding the triggering period of the thyristors. Clear? Yes. Next, what we are going to do? Anyway, I said, when we are looking for 3-phase full wave rectifier, we are going to develop waveform for line voltages. Sorry for the disturbance. We are going to develop the waveform for line voltages, not for phase voltages, right? I said, because if I am going with the line voltages, the way of analysis will become easy for me. That's why I am just going up with the what? Line voltages. There is no mandatory conditions at all. Okay? Yes, I understood. Okay. Shall we draw the waveform now? Yes. Our next target is we have to develop the waveform for the given circuit, right? Okay. Let me show you how to draw the waveform. Same way, right? First, draw the phase voltages. Yesterday, whichever the things that have been concluded, we can repeat, right? So let me do it. First, let us draw the waveform. First, let us mark the angles: 30 degree, 60 degree, 90, 120. We can go up to that margin only, right? So this is 150. I cannot go. What shall I do? I don't have space. Okay, let me try to restrict, because we don't have space. We try to quickly we draw with some restricted values. Let us take 30 degree here. Let us take 60. Let us take 90, 120, 150, 180, 210, 240, 270, 300, 330, 360. I am just considering one cycle, right? I hope these things are, it is visible for you all. Let us see. So the first signal, where it will start? The first signal will start at the origin and it will going to cross 180 degree and then it will be terminated at 360 degree, such that it will become this waveform, right? This waveform will become, it will cross 180 degree and then it will going to touch 360, right? So let us complete. So the first waveform will go like this. Developing the waveform is very important. Let us go with that is phase A voltage. Phase B voltage, what it will do? Phase B will start after 120 degree, right? So the displacement. Phase B will going to start from here. Now 120 plus I am in of what? 180, right? 120 plus 180 in the sense each and every half cycle will carry 180 degree, right? So 120 plus 180, 300, right? So it will complete second cycle. It will go like this. Yes. I know this waveform is not looking like a purely sinusoidal one. Please should try to draw a perfect waveform. Spend few minutes, right? Nothing is going to happen, right? Similarly, in the back side, 30, 60, 90. Exactly at 90, it will attain its maximum value and then it will go like this, right? Yes. Fine. When we are looking for next waveform, right? After 120 phase B will enter and then from here after 120 phase C will enter, right? If you observe phase C waveform will giving its presence from this point onwards. Prior to that, if I subtract 180 degree from this, again in the negative half cycle you will have 180. அப்ப இதுல இருந்து நீங்க 180 subtract பண்ணீங்க அப்படினா you are getting 60 degree, right? So it will become next waveform, right? Such that it will go 60 in the sense it won't touch maximum value somewhere here. That's all, right? So totally we have drawn three waveforms here. Yes, those are all what? This is BC. Yes, this is phase A voltage. This is phase B voltage. This is phase C voltage. Now we are going to observe some beautiful observations here. Once again, now tell me what is the minimum period of the thyristor triggering angle? I said if you want to, right? If you want to consider the leg number 1. Getting back, listen here. Now, before understanding these things, take your fully, that is 3-phase full wave rectifier. In this case, in each and every leg, we have 2 switches. One switch will going to take, that is this switch will be turned on with the help of positive voltage, and whereas while talking about switch 4, we are talking about negative voltage. Which negative voltage we are going to consider? See, in leg number 1, we are considering phase A. So phase A positive voltage will going to turn on thyristor T1. Phase A negative voltage will going to turn on thyristor T4. Similarly, phase B positive voltage will going to turn on thyristor T3, negative voltage will going to turn on thyristor T6. Phase C positive voltage will going to turn on T5, negative voltage will going to turn on thyristor T2. You might be wondering, sir, negative voltage vechna நம்ம எப்படி turn on பண்ண முடியும்? And the thing is, listen, phase A voltage it has two off, right? One is positive, another one is negative. Yes or no? Positive cycle consider பண்ணும்போது here you will have positive terminal, so here you will have plus polarity. If it is plus, then here it is going to be minus. If it is plus, then the opposite. Here it is going to be minus. If you notice these two thyristor, I can turn on this thyristor because across anode we have positive, across cathode we have negative. This thyristor won't be turned on. Whereas when we are looking for negative cycle, in the negative cycle polarity will be reversed. Here you will have minus, here you will have plus, here you will have plus. Such that I cannot turn on this thyristor, but I can turn on this thyristor. Yes. So negative half of the supply will going to turn on. Thyristor T4 will be triggered. It can be turned on when the supply of the phase A will be reversed, negative. Similarly, all the legs we can follow negative phases for lower legs. Upper legs will follow positive voltage of the phase voltage. Right? That's all. That is how we are triggering the circuits. Okay. Next thing we have understood. Next, what I am going to do? Each and every thyristors are going to be triggered with the displacement of what? 60 degree. Shall we start? Yes. We have to draw the various waveforms now. Anyway, I said I am going to draw the waveform for line voltages. But here, whereas here I have drawn phase voltages. Now we all know how to get the line voltage from phase voltage. How to get the line voltage from phase voltage? Let me rub these things. I don't have space here. Let us see how to get those things. So the thing is, if you want to know the line A voltage, that is AB voltage, how will you get that one? That is very simple. That is how it can be done as VA minus VB. So by subtracting phase A voltage and phase B voltage, we can obtain the value of VAB. Exactly, that is true. Similarly, if you want to know the value of VBC, then it can be written as VB minus VC. Similarly, if you want to know the value of VCA, then you can just subtract VC minus VA. That is how we are obtaining the line voltages at the various points. Clear? Yes. And the next thing is, you all remember, you all have to keep these things. VA can be written as Vm sin omega t. Exactly. VB can be written as Vm sin omega t minus 120 degree displacement. Similarly, VC can be written as Vm sin omega t plus 120 degree. Clear? That is how we are writing phase A, phase B, phase C. I hope these things are visible for you all. This is VA, this is VB, and this is VC. Phase voltages. Clear? From this, let us draw the line voltages. Right? Let us see. Now, let me take this circuit. Right? Let us take and let us draw the waveform with respect to omega t. Yes. Till now we don't have any problems, right? Now, the question is, at which time period which thyristors are going to be triggered, right? Hopefully, you have to think about these things. That is very simple. Listen, I said in each and every time period, in each and every triggering period, two thyristors are going to be continuously turned on. ரெண்டு thyristors எப்பவுமே on state ல இருக்கும், right? A pair of thyristors will going to contribute with one pulse. Similarly, each and every pair will going to generate 6 pulses here. Let us see how they are going to do those things, right? Initially, we all know, if you want to turn on, நீங்க thyristor வந்து turn on பண்ணனும் அப்படினா what will be the minimum time period? The minimum time period to turn on the thyristor is 30 degree. Yesterday only we saw, when I was discussing about the half-wave rectifier, I only told you, see that because of the free dominant effect of the phase C positive voltage, we are unable to trigger the thyristor T, that is thyristor T1, prior to this positive voltage. If you want to turn on the leg 1 voltage, right? If you want to turn on the leg 1 thyristor, you have to wait for up to what? 30 degree from this point onwards. After this 30 degree, you can turn on the thyristor. That things we understood in the last class. Now what I am going to do, so the minimum angle, if you want to turn on the thyristor, at least you will have to start at omega t equal to 30 degree, right? So we can start at omega t equal to 30 degree. That is the minimum angle. And then with this you can add the value of alpha, right? So if you want to, அப்ப நீங்க எந்த பாயிண்ட்ல வந்து thyristor வந்து turn on பண்ண போறீங்க அப்படிங்கிறது, see, the on time of the thyristor is depending on two people. One is 30 degree, that is always fixed initial value, plus alpha. And with this what will happen, you can run up to, if starting first thyristor will be triggered at 30 plus alpha, then from here you will have to wait for what, next 60 degree க்கு அப்புறம் அடுத்த thyristor வந்து நீங்க turn on பண்ணனும். So if the first thyristor will be triggered at 30 plus alpha, then the next thyristor will be triggered at 90 plus alpha. Is there any mistake in my conclusion? No. See that 30 first thyristor வந்து நீங்க 30 degree ல வந்து trigger பண்றீங்க அப்படினா, அடுத்து நீங்க displacement எவ்வளவு கொடுக்கணும்? நான் என்ன சொல்றேன், we are going to generate 6 pulses. In the sense, 6 pulses in the sense, each and every thyristors are simultaneously triggered with the 30 degree displacement. If your first thyristor will be triggered at 30, then the next thyristor will be triggered at 90, and then the next thyristor will become 150, 210, 270 and so on. Clear? Yes. So let us go ahead with that. So I understood. This is the first thyristor that is going to be triggered with the value of 30 plus alpha. Now let us make the value of alpha as 0. Initially I am going to consider once again alpha equal to 0 degree. Triggering angle. அப்ப alpha value வந்து 0 degree கொடுத்துட்டீங்க அப்படினா, thyristor T1 will going to be triggered at what? Thyristor T1 will going to be exactly triggered at 30 degree, right? Now hopefully let us understand. It's really quite interesting. So the thing is, where is 30 degree? This is the 30 degree point, right? So here only we are going to trigger the first thyristor. Thyristor T1 will be triggered here. Next what will happen? From here, after 60 degree. After 60 degree results 30, 60, 90. Exactly at this point, we are going to trigger the next thyristor. Let me draw here. So next thyristor results thyristor T2. Just we are going to trigger them simultaneously, right? Sequence. Similarly, from here after 60 degree, 30, 60, 90, after 90 degree, we are going to trigger the next thyristor T3. We are going to trigger thyristor T3. Similarly, from here after 90 degree, sorry 60 degree. Did I make any mistake here? 30, 60. Sorry guys, this is sorry. I did not notice. Displacement how much? 60 degree, right? So 30, you will have to wait for 60 degree. Next thyristor will be triggered here. T2, next after 60 degree, not 90 degree, not 60 degree displacement. I registered this one in my mind. 30, 60, right? At 150 degree, we are going to register. That is, we are going to trigger next thyristor T3. After 30, 30, 60 degree, we are going to trigger thyristor T4. Next 30, 30, next 60 degree. After 60 degree, we are going to trigger thyristor T5. Next after 30, 30, at 330, we are going to trigger thyristor T6. One cycle, just to consider one cycle. Now see that in a complete cycle, T6 is being triggered at 330 degree. Adukapra 60 degree the connection irukuma. Yes, 332. Adukapra 60 degree kappuram we have to trigger the next thyristor. It means 330 we are triggering the T6. After 330 to 360 we will have 30 degree displacement, getting back to the starting point. From 0 to 30 we will have one more 30 degree and then T1 will be triggered. I am just considering a rotation. Only within 360 degree we are going to get this simultaneous sequence. Same thing it will going to can observe repeatedly because we are in periodic signal, right? So you don't need to be bothered about the after 360 degree. 360 degree ku appuram neenga observe பண்றது நீங்க ஒரே செகண்ட்ல திரும்ப பேக்ல வந்து நீங்க பாத்தீங்கன்னா you are getting the same sequence. It's like a train, right? There is no changes. Fine. So what is the conclusion here? So totally we are going to trigger 6 thyristors here. Did you understand? Yes. Appo first thyristor நம்ம எங்க டர்ன் ஆன் பண்ண போறோம்? We are going to trigger the first thyristor at T1. Now we have to measure the line AB voltage. Let us measure. அப்ப line AB கிடையாது. We are going to measure the output voltage. But அந்த output voltage வந்து நமக்கு எப்படி கிடைக்க போகுது? The thing is which line voltages we are going to measure. Whether thyristor T1 வந்து trigger பண்ணும்போது நமக்கு என்னென்ன voltagesலாம் வந்து ஆன்ல இருக்கும். எந்தெந்த legs எல்லாம் ஆன்ல இருக்கும் அப்படிங்கறத நீங்க வந்து find out பண்ணனும், right? So the first thing is prior to T1 which thyristor will be already in conduction? T6. Yes or no? See there 330 la irundha up to 30 T6 already in conduction, right? So let us see prior to this point, prior to T1 already T6 in conduction. Ipo நம்ம என்ன பண்ண போறோம்? With this T6 we are also going to trigger thyristor T1, right? So exactly at omega t equal to 30 thyristor T1 also being triggered such that from T1 up to the next interval, in between this interval T6 and T1 both are in conduction. I will let you know, slowly you will understand, right? So first T6 already in connection. We are not going to turn off thyristor T6, but we are going to turn on thyristor T1 also, right? So இதுக்கு முன்னாடி அப்ப T6 கூட வேற ஒரு person இருந்திருப்பாரு. அந்த person off ஆயிட்டு T1 இப்ப turn on ஆகும். You will understand. Sequence அப்படியே வரும்போது உங்களுக்கு புரிஞ்சிரும். So anyway here at this point T6 already in connection, we are triggering thyristor T1 now, right? At this point we are triggering thyristor T1. Now T6 already in connection. Now I am triggering thyristor T1 also. See there. Lower leg in the sense we have to consider negative voltage, upper leg in the sense we have to consider positive voltage. அப்ப இங்க T6 அப்படிங்கிறது யாரோட voltage? Phase B negative. T1 அப்படிங்கிறது phase A positive. Such that let me run these things now. Let me teach you how to get the answers at all. Slowly observe this. It's actually very very easy, right? If you keep your concentration. Let us see. See the first one நம்ம என்ன பண்ணிருக்கோம் ஆல்ரெடி T6 in conduction T1 இப்ப நீங்க ட்ரிகர் பண்ண போறீங்க ரைட் two switches always in conduction you will get the idea நான் ஒரு 2 or 3 cycles போடுறப்ப உங்களுக்கு ஐடியா வரும் கேர்ஃபுல்லா அப்சர்வ் பண்ணுங்க T6 அப்படியே ஆன்ல இருக்கா let us trigger T1 ட்ரிகர் பண்ணியாச்சு T1 voltage is positive so first consider positive voltage VA is positive whereas with this we are triggering T6 அப்படிங்கிறது lower leg in the sense we have to consider the negative voltage so B is negative B on the second level. So VAB, we are measuring VAB. So VAB is known as VA minus VB. VA minus VB. அப்ப நம்ம எப்படி எழுதலாம்? Can be written as VA phase A voltage can be written as VM sin omega t. Just now I have written here minus phase B voltage can be written as VM sin omega t minus 120 degree. Yes or no? Exactly that is true, right? So let us estimate its value. எந்த பாயிண்ட்ல நம்ம இப்ப கால்குலேட் பண்ண போறோம்? At this point. See that exactly at this point I would like to know the value of VAB. Exactly at this point I would like to know the value of VAB. இந்த பாயிண்ட்ல what is the value of omega t? Omega t equal to 30 degree. Carefully observe here. At last I will demonstrate. We will do some analysis in the waveform itself. You will get the clear idea. But right now I am not going into that one. Just to take this one. See there is the waveform. Omega t is going to be 30 degree. Exactly when the moment, where the moment we are triggering the thyristor, value of omega t is going to be 30 degree. So replace omega t by 30 degree in order to get the value. So it is going to be Vm sin 30 minus Vm sin of 30 minus 120 will become minus 90 degree. We all know sin of minus theta can be written as minus sin theta. Already we have one more minus, so this function will become plus. Sin of minus theta can be written as minus sin theta. Already we have a minus in front of sin, such that minus into minus will become plus. Since sin 90 is equal to 1, sin 30 is equal to 1 by 2. So 1 by 2 into 1 will become what? 1.5. So the net voltage VAB should be equal to 1.5 times of maximum voltage Vmax. Clear? So let us see at omega t equal to, right, what I can say 30 degree, we are getting 1.5 times of Vmax. Clear? Let us continue. Next, let me rub this one. Let us calculate some values in between thyristor T1 and T2. Next, we are going to trigger the next thyristor at T2, right? So now I would like to craft some value in between this. Here I have 1.5. I would like to know at omega t equal to 60 what is the value of the system. Anyway, see listen. We are going to trigger the next thyristor at omega t equal to 90 only. Up in between T1 and T2 during this gap. Up in the gap which thyristors are going to continuous conduction? Thyristor T1 and T6 will continuous its conduction until the arrival of the next junction. This is our next junction. So before reaching the next junction, two trains are going to travel now. One is train T6, another one is train T1. Both are traveling towards junction T2. After junction T2 reach பண்ணதுக்கு அப்புறம் train வந்து நம்ம மாத்த போறோம், right? ஒரு train அங்க ஸ்டாப் பண்ணிட்டு இன்னொரு train நம்ம எடுக்க போறோம். That things we'll see later. Anyway, in this journey, intermediate point at omega t equal to 60 also I would like to know the value with the same voltages T1 T6. Once again same voltages VAB only. But I would like to know this value at omega t equal to 60 now. Let us estimate. Once again, Vm, shall I write the answer directly? That is Vm sin omega t can be replaced by 60 minus Vm sin omega t is 60 minus 120. Keep cancelling with you all. So it can be written as what? Vm sin 30 can be written as root 3 by 2. Yes, that is correct. Minus Vm divided by, let us see, 60 minus 120 will become what? Once again 60. That is sin 60. But what's wrong with this? We are getting minus sin 60. Minus sin theta. Sin of minus theta will become minus sin theta. Once again it will become plus. Same sin 60. Here also same sin 60. This also become, see the root 3 by 2 of any root 3 by 2 down. Right? So shall we club them together? Twice of root 3 by 2. Finally we are getting root 3 times of Vm. I am repeating once again. Listen. 60 minus 120 will become minus 60. Sin of minus 60 will become minus sin 60. Already we have a minus, such that it will become plus. So Vm sin 60 plus Vm sin 60 will become 2 times of Vm sin 60. Value of sin 60 is root 3 by 2. I have one more 2. 2 getting cancelled, we are getting root 3 times of Vm. So the answer is going to be what? 1.732 times of maximum voltage, right? So let us substitute exactly at the midpoint. At the midpoint. So here we are going to get, let me learn these things now. This is going to be 1.732 times of Vmax. Clear? Yes. Slowly observe. Next, exactly at omega t equal to 90, what we are going to do? At omega t equal to 90, thyristor T2 will be triggered. Now we have to notice. Listen guys, listen. If you notice always we are measuring line voltage. So line voltage in the sense it might be VAB or VBC or VCA, whatever. ஏதோ ஒரு voltage நம்ம measure பண்ண போறோம். ஆனா நீங்க measure பண்ற line voltageல definitely one quantity is positive, another one quantity is negative. Do you agree? You have to agree here, right? அப்ப இந்த ரெண்டு பேர்ல கண்டிப்பா ஒரு quantity வந்து நெகட்டிவா இருக்கும். Now at omega t equal to 90, we are going to trigger thyristor T2. Thyristor T2 அப்படிங்கிறது lower legல இருக்க இல்ல upper legல இருக்க பாருங்க, it is in lower leg. அப்ப thyristor T2 வந்து lower legல இருக்க T2 நீங்க trigger பண்ண போறீங்க அப்படினா இதுக்கு முன்னாடி lower legல எந்த thyristor onல இருந்ததோ that thyristor will be forced to turn off, right? See, it will be naturally turn off. How it is naturally turn off? If you notice the waveform carefully, right? Actually இப்ப நம்ம waveform வந்து நான் இங்க வந்து waveform வந்து கரெக்ட்டா தப்பா போட்டுருக்கேன். கரெக்டா இந்த 90 டிகிரி நேரா இந்த வேவ்ஃபார்ம் இங்க வரும் ரைட். see இந்த பாயிண்ட்ல தான் 90 டிகிரி வரும் உங்களுக்கு ரைட். இங்க 90 வருது இல்லையா, அதே இடத்துல we are getting this one. see actually at this point only we are getting omega t equal to 90. அந்த டைம்ல ரைட் t2 வரும். anyway டயகிராம்ல என்னால அது கரெக்ட்டா வரைய முடியல, you can do it right. so அப்ப இங்க என்ன நடக்கும்னா see there இது வரைக்கும் யார் வந்து மோர் நெகட்டிவா இருக்கு சார், இது யாரோட வேவ்ஃபார்ம் பாருங்க, VB phase B. phase B ஓட வேவ்ஃபார்ம் is more negative. see there more negative. we have three waveforms in between 0 and 90. in between 0 and 90 we have three waveforms, phase A, phase A, phase C, phase B. out of these three waveform which is more negative, this one. more negative in the sense we have to keep more dip in negative portion. this is more negative, that's why this thyristor was keeping its connection. but after 90, this is the 90 degree point. I am repeating once again in the graph. I had been noticing these things. நான் எழுதும்போது தப்பா எழுதிருக்கேன் ரைட். கரெக்ட்டா வேவ் ஃபார்ம் வந்து இந்த இடத்துல கிராஸ் பண்ண இடத்துல 90 டிகிரி வரும். நீங்க அதை கரெக்ட்டா போட்டுக்கோங்க ரைட். சோ அப்ப இந்த இடத்துல எப்படி நடக்கும்னா see there after this point this portion is increasing, this portion is decreasing such that VC will become more negative. VC அப்படிங்கிறது phase C. phase C ல இருக்க நெகட்டிவ் லைட் யாரு, T2. அப்ப T2 தான் டர்ன் ஆன் ஆகும் கரெக்ட்டா. always two people will turn on. one is more positive voltage with more negative voltage will be in conduction. அவ்வளவுதான். இப்ப பாருங்க VAB அப்படிங்கிறது T1 T6 நம்ம டர்ன் ஆன் பண்ணோம் ரைட். T1 T6 இப்போ இந்த ஃபர்ஸ்ட் டூ திங்ஸ் இதுக்கு முன்னாடி நீங்க வேவ் ஃபார்ம் அப்சர்வ் பண்ணி பாத்தீங்க அப்படினா இந்த T1 க்கு T2 க்கு நடுவுல பாருங்க, T1 க்கு T2 க்கு நடுவுல we are keeping T1 and T6 in conduction. T1 அப்படிங்கிறது இப்போ யார் இதுல மோர் பாசிட்டிவா யார் இருக்கா, VA is more positive. VA is more positive. அதே இடத்துல மோர் நெகட்டிவ் யார் இருக்கா, T6, that is VB. VB is more negative. so T1 T6 will be in connection. நீங்களே இப்ப கண்டுபிடிச்சலாம். இப்ப அடுத்து பாருங்க இந்த வேவ் ஃபார்ம்ல இதுல யார் மோர் நெகட்டிவா இருக்கா, இந்த ஜோன்ல actually in this zone more negative is DC. இத third C லைன் phase C லைன்ல more negative in the sense T2. at the same time அதுல more positive யார் இருக்கா, T1, that is VA. T1, so T1 T2 will be in connection. like in the waveform வச்சு நீங்க அப்சர்வ் பண்ணிக்கலாம் கரெக்ட்டா right. that is what I can told you. from the waveform itself we can draw, but thyristor நீங்க எந்த பாயிண்ட்ல ட்ரிகர் பண்றீங்க அப்படிங்கறதும் இம்பார்ட்டன்ட். anyway in this case we are triggering the thyristor at alpha equal to 0 degree. so whichever the waveformsல என்ன changes வருதோ அதை ஃபாலோ பண்ணி thyristor அப்படியே ஆன் ஆயிடும் immediately right. let us see. so the conclusion is at omega t equal to 90 degree right. so thyristor T2 will be triggered. it means where is the thyristor T2 in the lower length. this thyristor will become more negative now, that is phase C voltage will become more negative. so immediately phase B is going to be turned off. but which is more positive, still thyristor A, that is phase A voltage is more positive. so thyristor T1 and T2 will continue its conduction. let us see. அப்ப இந்த பாயிண்ட்ல once again we have to estimate the value. shall we calculate? now I would like to know the voltage at this point at omega t equal to 90 degree. I would like to know the value of voltages right. let us estimate. first omega t equal to 90 degree la enna voltages irukku parunga, which legs we are going to consider. let me write this one also. now at omega t equal to 90 degree we are going to consider thyristor T1 and T2 right. so thyristor T1 and T2 அப்ப இது கரஸ்பாண்டிங் வோல்டேஜ் யாரு எழுதுறீங்க, T1 more positive, so I have to consider A. T2 இங்க இருக்கு, இது என்ன லெக், C ஓட நெகட்டிவ் லெக், so VAC. VAC எப்படி எழுதுறீங்க, it can be written as Vm sin omega t minus Vm sin omega t plus 120 degree. yes or no, that is phase C voltage. now if I substitute Vm sin omega t can be replaced by 90 degree. that is T will be triggered at 90 degree. clear. so minus Vm sin, let us write the answer. 90 plus 120 will become 210. 90 plus 120 will become 210 right. let us estimate this value. take your calc right. I have a calc with me, so just to open your calc. okay, just listen, I will do it, no problem. 210, I would like to know the value of 210. just we have to take sign. I am getting minus 1 by 2. already we have minus right. so minus of minus 1 by 2 will become plus 1 by 2. sin 90 is 1, so 1 plus 1 by 2 will become 1.5. once again 1.5 times of Vm right. so again we are getting same value, we are getting 1.5 times of Vm. let us see. next thyristor T3 will be triggered here. can you estimate? அப்ப அடுத்து இமிடியேட்ல இப்போ நீங்க ஒரு வேல்யூ கால்குலேட் பண்ணி வெச்சுக்கோங்க. 1. நீங்க 120 ல வேல்யூ கால்குலேட் பண்றீங்க அப்படினா you will get once again 1.732 times. So times of maximum voltage. How will you calculate? At omega t equal to 120, same waveform. Thyristor T1 and T2 will be in conduction. See that in between T2 and T3, who are all going to, which trains are going to travel? Train number T1 and train number T2 will going to travel. T6 train off பண்ணிட்டீங்க. Just now I have been stopped him. In the train stop பண்ணிட்டு in the train start பண்ணியாச்சு, right? Now these two trains are carrying the passengers. Next what we are going to do during this journey in between T2 and T3, these two trains are going to carry the passengers. In the sense, what I am going to do in between, ஏதோ ஒரு பாயிண்ட்ல வந்து I would like to know the ability of the train. அப்போ omega t equal to 120 ல what is the maximum voltage? Omega t equal to 120 னா just replace omega t equal to 120 here. இங்கே 120 substitute பண்ணுங்க, you are going to get 240. Here you are going to get 120 such that ரெண்டுத்தையும் கிளப் பண்ணீங்கன்னா once again you are going to get 1.732 times of Vm only. That is root 3 times. கரெக்ட்டா வரும், right? You can cross it. Next, and then at 150 degree, at omega t equal to 120, we are triggering thyristor T3, right? So we are going to trigger thyristor T3. Let's see what happens. Thyristor T3, inner of the mind inner friction on all of that. Thyristor T3 upper leg la irukka, lower leg la irukka, upper leg la irukka. Upper leg in the sense positive voltage. அப்ப இதுக்கு முன்னாடி யார் பாசிட்டிவ் இருந்தது? T1. It will be turned off. Now T3 will go into turn on. Only one positive voltage you can consider. Or else you can consider here also. See there, omega t equal to 150 degree நீங்க observe பண்ணீங்கன்னா see there. Phase A voltage இது வரைக்கும் யார் more positive இருந்தது? Phase A. Now exactly at this point, phase A voltage is decreasing. Phase B will become a superstar now. Phase B will become more positive. So automatically after 120 degree, we can trigger phase B. Without phase B, phase B the more positive is T3. So T3 will be triggered. Right? அதே டைம்ல more negative யார் இருக்கிறது? Still VC is more negative. Yes or no? இவங்க மூணு பேர்ல which is more negative? இத கம்பேர் பண்ணுங்க. In these levels V3, that is VC is more negative. VC third leg more negative in the sense we have to consider lower leg T2. So who are going to continue their conduction? T2 and T3 will going to continue this conduction from this point, right? So let us see. Now we have to estimate the value at this point, right? Let us see. Now we என்ன பண்ண போறோம் exactly at this point. Which train is going to be stopped now? We are going to stop the train number T1. இதுல இருக்க passenger நீங்க இப்ப இதுக்கு ஷிஃப்ட் பண்ணனும். T3 க்கு ஷிஃப்ட் பண்ணி once again T2 and T3 will going to carry the passengers from T3 to T4. Shall we continue? Yes. Let us estimate. Next we are going to consider T3 and T4. T3 T4, right? So T3 T4, which is positive, which is negative? Upper leg is positive, right? So let us see. V upper leg, where is upper leg? This is. இதுல யார் இருக்கா? என்ன வோல்டேஜ் இருக்கு? phase B voltage. So VB. Lower leg is T4 எங்க இருக்கு? இங்க இருக்கு. அது என்ன leg? VA. T4 or T2? What is this? We are starting at this point, right? We are going to, sorry, I meant to say this is T2 only. So VBC. We are going to consider VBC. Train number T3, train number T2, T2 VC, right? So shall we write? It can be written as VM. See, I don't have space here. Let me slightly extend. Let me write here. VBC can be written as VM sin omega t plus minus 120 minus VM sin omega t plus 120 degree. Shall we proceed now? Yes. ஆனா எந்த பாயிண்ட்ல இருக்கீங்க? thyristor T3 will be triggered at omega t equal to 150 degree. Let us replace. அப்ப omega t க்கு பதிலா if I replace omega t by 150, then what I will get? 150 minus 120 will become 30 degree. Sin 30 is how much? 1 by 2. Vm by 2. Next, here also I am going to repeat the same thing, right? 150 such that 120 plus 150. Let me add it is going to be 270, right? So let us see. We have to estimate the area of 270 now. Let us see. I have to take the calc 270. We have to take sin of 270. I am getting minus 1. So minus 1 into we know 270 sin 270 minus 1 minus. See that I am using calc for this. Minus 1 into minus 1 will become plus. Already we have one more minus now. So that is become plus Vm. So exactly that is equal to what? 1.5 times of Vm. So again let us extend our discussion. That is 1.5. Did you notice? அப்ப இதுக்கு அப்புறம் wave form ல என்ன வேல்யூஸ் வரும்? உங்களுக்கு புரியுதா? ஃபர்ஸ்ட் என்ன வேல்யூ வந்திருக்கு பாருங்க. At very first I found at omega t equal to T1. thyristor வந்து நம்ம trigger பண்ணப்ப, right? And triggering thyristor trigger பண்ணும்போது we are getting 1.5 and then 1.732. In between intermediate point will give you 1.732. Again we are getting 1.5, 1.732, again 1.5. Let us extend our discussion. அப்ப நீங்க திரும்ப 180 டச் பண்ணீங்க அப்படினா it will be 1.732. Next at thyristor T4 trigger பண்ணும்போது you are going to get 1.5. Again at 240 you are going to get 1.732. Again next thyristor trigger பண்ணும்போது 1.5. Again at 300 you are going to get 1.732. At T60 okay again you are going to get 1.5 only, right? So if I join all the points, let us see. அப்ப waveform எப்படி இருக்கு? Initially it is 1.5 and it is raising to 1.732. Again it is decreasing to 1.5. Again it is raising to 1.732. Decreasing to 1.5. Again raising to 1.732. Decreasing to 1.5. Again raising to 1.732. Decreasing to 1.5. Raising to 1.732. Decreasing to 1.5. And then again we will raise to 1.732. Again let us here you have one more half. Such that how many pulses is being generated? See there. Here I have one half, right? Here we have one half. We have to consider that 360. 360 வரைக்கும் நீங்க போகணும். இங்க ஒரு half இருக்கு, இங்க ஒரு half இருக்கு. Totally 1. So 1 2 3 4 5 6. Yes. Successfully we are getting 6 pulses, right? So that's why it is called 6 pulse converter. See how beautifully we are getting there. Nothing to understand. Just you have to learn how to apply this technique, how to find out the line voltages at the various points, right? So at the alpha equal to 0 degree, are you getting continuous conduction or not? Yes, we are getting continuous conduction. Do you have any discontinuity? No. Voltage level is what? Just it is maximum level of the voltage level will be 1.732, minimum voltage level will be 1.5. So the level of the voltage is being bounded in between 1.73 to 1.5, right? So in case at alpha equal to 0 degree, right, the maximum peak voltage it will be bounded between, right? So the level of the maximum and the minimum voltage is bounded between what? It belongs to 1.5 to what? 1.732. That is the voltage levels when we are having the value of alpha equal to 0 degree. And did you notice, don't forget this one, for continuous conduction each and the thyristor triggering period is what? We are triggering the thyristor between 30 plus alpha to 90 plus alpha. By using this only we are going to find out the V0 average for continuous conduction, because first thyristor will be triggered at 30 plus alpha, second thyristor will going to be triggered at 90 plus alpha. In between these two triggering variations we are going to, what I can say, we are trying to get continuous conduction. Shall we raise the LF alpha? Yes. Let us raise the LF alpha. Let me make the LF alpha as, shall we keep 30 degree? Yes. Let us keep the LF alpha equal to 30 degree. I am going to rub this waveform, but please don't do that one. Extend on your note, the x-axis on the extend பண்ணிட்டு கீழ one more axis வரைஞ்சிட்டு second keep alpha equal to 30 degree. Repeat the same procedure. Let us see what happens. Let me run this one, right? Let us make alpha equal to 30 degree, right? Let us extend the axis once again, omega t. Shall we start? Yes. But before starting, we should shift the position of the thyristors. Why? We are going to trigger the thyristor at the alpha equal to 30 degree now, right? 30 degree in the sense I will have to shift the positions. அப்படினா மீனிங் என்னங்க, usually alpha will be triggered, right? The on time of the thyristor, that is on position, right? On time, right, is depending on the value of 30 degree plus alpha. Now alpha is fixed as 30 such that 30 plus 30 will become 60 initial. First thyristor will going to be triggered at 60 degree now, right? Such that, let me rub this one. Let us place the thyristor at this position, right? Let us place the thyristor at this position. And second thyristor will be placed at this position. Third thyristor, see there. First thyristor 60 degree அப்படினா from 60 after 60 degree at omega t equal to 120 we are triggering the thyristor T2. So you can remove this one. And then third thyristor, right? So third thyristor T3 will going to be triggered at omega t equal to 180. That is from 120 after 60 degree we are going to trigger thyristor T3, right? Let us rub this one. அப்ப T4 எங்க trigger ஆகும்? From 180 after 60 degree. After 60 in the sense 240. At 240 we are going to trigger thyristor T4. Now from here after 60, 240 plus 60 will become 300, no? Yes. From here at this point we are going to trigger thyristor T5. Now from here after 60 degree we are going to trigger thyristor T6. Yes. அப்ப 360 டிகிரில thyristor ட்ரிகர் பண்ணீங்க அப்படினா consider simultaneously அப்படியே நீங்க ரொட்டேட் கொடுத்தீங்கன்னா திரும்ப T60 வந்து T6 இங்க தான் ஸ்டார்ட் ஆகுது. இங்க இருந்து 60 டிகிரி கனெக்ஷன் வரணும் and then T1 will turn on. Again this train pulse is being repeated again and again. These people are going to be rotates, right? They are going to continuous their cycle, right? Shall we draw the waveform? Yes, drawing the waveform is our responsibility. Let us draw the waveform. Okay, just go ahead. Start now. First let us start at omega t equal to 60 degree. Who are all going to be in conduction? Endha playlist la conduction la irukku parunga. Let us check. I know prior to T1 already there is a T6 in conduction. Same sequence. So by now we all know in between T1 and T2 there is a T6 T1. Two trains we are going to use here. One is there is a T6, there is a train T6 and a train T1. So these two trains are going to carry the passengers. And then after reaching T2, right? இங்க சிம்பிளா அண்டர்ஸ்டாண்ட் பண்ணிக்கோங்க. உங்களோட ஸ்விட்ச் நம்பர் வந்து ஈவன் நம்பர்ல இருக்கு அப்படினா இதுக்கு முன்னாடி இருக்க ஸ்விட்சிங் பேர்ல ஈவன் நம்பரை ரிமூவ் பண்ணிடுங்க. ரைட்? இப்போ அடுத்து வந்து ஸ்விட்சிங் நம்பர் நீங்க ட்ரிகர் பண்ண போற ஸ்விட்சிங் நம்பர் ஆட் நம்பர்ல இருக்குனா இதுக்கு முன்னாடி இருக்க ஸ்விட்சிங் பேர்ல இருக்க ஆட் நம்பரை ரிமூவ் பண்ணிடுங்க. அவ்வளவுதான். There are no big things to understand, right? So like that if I consider see that here we are going to consider T1 and T6. Let us consider T6 T1 நம்ம கன்சிடர் பண்ண போறோம். அடுத்து நீங்க பாருங்க T2 தான ட்ரிகர் பண்றீங்க. T2ங்கிறது ஈவன் நம்பர் தானே. அப்ப இதுக்கு முன்னாடி இருக்க ஈவன் நம்பரை ரீப்ளேஸ் பண்ணிட்டு now keep T1 T2 நியூ ஈவன் நம்பர். அடுத்து பாருங்க ஆட் நம்பர். அப்ப இதுக்கு முன்னாடி இருக்க ஆட் நம்பரை ரீப்ளேஸ் பண்ணிட்டு let us consider T2 T3 நியூ ஆட் நம்பர். அடுத்து T4 நியூ ஈவன் நம்பர். அப்ப ஓல்ட் ஈவன் நம்பர் ரீப்ளேஸ் பண்ணிட்டு ரைட் கன்சிடர் நியூ ஈவன் நம்பர். and then see that T5 அப்ப old odd number replace பண்ணிட்டு consider new odd number அப்படியே வரும் T4 T5 see that and then old odd number replace பண்ணிட்டு sorry old T6 ல even number old even number replace பண்ணிட்டு new even number consider பண்ணிக்கணும் see that அப்ப இங்க யார் இருக்க கனெக்ஷன்ல ஃபர்ஸ்ட் T5 T6 இவங்க ரெண்டு பேர் தான் கனெக்ஷன்ல இருப்பாங்க அதுக்கு அப்புறம் யார் ஆகும் again T1 வரும்போது இதுக்கு முன்னாடி இருக்க odd number replace பண்ணிட்டு we are considering T1 see that this switching sequence its pattern is being repeated. Shall we continue? Yes, let us start our journey now. So when the moment at omega t equal to 60 we are going to trigger thyristor T1 such that I would like to know the voltage exactly at this point triggering point right. So if you want to know that one shall we estimate? Yes, T1 T6 again T1 upper leg positive voltage phase A so it can be written as VA. T6 lower leg negative voltage phase B so VAB. It can be written as VAB. We know how to write Vm sin omega t minus. Do it by yourself because I hope you all have understand the procedure how to do these things. Substitute பண்ணலாமா omega t ஓட வேல்யூ எவ்வளவு we are standing at omega t equal to 60 degree right so omega t is going to be replaced by 60 degree such that what will happen Vm into sin 60 ஓட வேல்யூ எவ்வளவு √3/2 we all know sin 60 is √3/2. Similarly, if I replace omega t by 60 degree here also, what happens? Sin 60 minus 120 will going to give us minus 60 such that sin of minus 60 will become minus sin 60 minus into minus will become plus sin 60 also going to be √3/2 so we have twice of √3/2 2 is getting cancelled out finally we are going to get 1.73 times of √3 right so initially I am getting some value here let us keep that value is what 1.732 times of maximum voltage. Let us proceed. Next what happened? Let us select some intermediate value. Intermediate value in the sense after 60 next consequent value is 90 degree. Let us see same take the same value but estimate it at omega t equal to 90 degree. Let us see VAB equal to at 90 degree in the sense omega t is going to be replaced by 90 omega t is going to be replaced by 90 degree such that we are going to get sin 90 will become 1 and here 90 minus 120 will give you minus 30 right just now we saw minus of minus will become plus such that what I am going to get now so here we are going to get plus 30 degree sin 30 1/2 sin 90 1 plus 1/2 1.5 so it is going to be 1.5 times of Vm. Notice these things see that initially we are having 1.732 and then your value will be reduced to 1.5 right so let us keep some other point somewhere here second value is going to be here now after reaching 120 let us see after reaching 120 here what happened thyristor T1 and T2 are going to be triggered right that is we are going to change the trains Till now, T6, T1 is carrying the passengers. Now T1 and T2 are going to carry the passengers in the sense T6 ல இருக்க passengers நீங்க T2 க்கு மாத்துறீங்க. T6 ல இருக்க passenger இதான். இத நீங்க யாருக்கு மாத்த போறீங்க? T2 க்கு மாத்த போறீங்க. Like that, T1 and T2 are going to be carrying the passengers. T1 upper leg is face A, lower leg T2 face C. So VAC. We are going to consider VAC. Right? Yes. I will let you know about these things. Slowly understand first. Right? So we are going to consider T1 and T2. Clear? Now T1, T2 once again, if you are estimating the value, what will happen? T1, T2 dana? Yes. T1 that is VA. Right? கொஞ்சம் தள்ளி எடுக்கலாமா? ஸ்பேஸ் கிடையாது. VA. T2 எங்க இருக்கு பாருங்க? T2 வந்து VC. That is VAC. அப்ப ஆன்சர் என்ன வரும்? That can be written as VM sin omega t minus VM sin omega t plus 120 degree. Clear? Exactly. If you are see there, we are standing at what? Omega t equal to 120 degree, right? Just to take your calculation, replace omega t by 120. Replace omega t by 120. Estimate the value, right? Estimate பண்ணீங்க அப்படினா, let us see. I do don't remember the other sin 120. Let us estimate. Sin 120 is root 3 by 2, right? Similarly, 240, I think it is minus root 3 by 2, right? Yes, that is minus root 3 by 2. Already become a minus. So root 3 by 2 plus root 3 by 2 will become twice of root 3 by 2. 2 getting cancelled. Root 3 times of v will become 1.732. Listen, after reaching this point, it is decreasing now. You might be wonder here. So if it decrease agudhu thiruma iga rise agudhu. Appo waveform eppadi varum? I will explain. Don't worry. First we will complete. At last I will give proof. Once again it is 1.732 times of Vm. அப்ப அடுத்த வேல்யூ என்ன வரும்? At 150 you can cross check. Again you are going to get 1.5 only. Clear? அதுக்கு அப்புறம் திரும்ப நீங்க 120 செக் பண்ணீங்க அப்படினா again you are going to get 1.732. Again at 210 we are going to get what? 1.5. And then again 240 we are going to get what? 1.732, right? So it will be continuous. Again at 270 you are going to get 1.5 only. Again at 300 you are going to get 1.732. Again you are going to get 1.5. Again you are going to get 1.732. Like that your waveform will be continuous. Sir, இது எப்படி நீங்க வரைவீங்க? So the thing is, in order to understand this waveform clearly, first let me draw the waveform for understanding. Listen, இப்போ எனக்கு waveform இங்க இருக்கா? It is decreasing actually. 1.73 ல இருந்து decrease ஆயிருக்கு. அப்ப இங்க decrease தான ஆயிருக்கும். Exactly. Right? இது எப்படி decrease ஆயிருக்குனா, it is see that, let me show you. Actually it is decreasing like this. அதுக்கு அப்புறம் என்ன ஆயிருக்குனா, there is an impulse. Suddenly this value will be raised. If you want to know the decreased value, இப்போ जी sir எனக்கு எக்ஸாக்ட்டா இந்த இடத்துல இந்த பாயிண்டோட வேல்யூ எனக்கு வேணும், மினிமம் வோல்டேஜ். If you want to know that one, just you have to test. Omega t equal to 120 degree we are going to trigger thyristor T2. Yes or no? Just before that fraction of second அந்த T2 trigger பண்றதுக்கு 1 செகண்டுக்கு முன்னாடி அப்படியே பாருங்க 0.001 செகண்டுக்கு முன்னாடி பாத்தீங்க அப்படினா T6 T1 will be in connection. Correct? Almost at the edge omega t equal to here 120, right? So 119.99999 varakum which thyristor will be in connection? T6. Train T6 will be in connection, right? So in order to know this value, it is past value, it is the present value. So if you want to know the value of past value, just take immediately only one point prior to that point, right? So let us test. அதுக்கு முன்னாடி actually எந்த thyristor வந்து ஆன்ல இருந்தது அப்படினா we have two thyristors, one is T6, another one is T1, correct? Such that expression was being written as VAB equal to Vm sin omega t minus Vm sin omega t minus 120 degree. We all know this one. T6 T1 was carrying the passengers prior to this point. Exactly at omega t equal to 120 degree only we are switching the passengers from T6 to T2. அதுக்கு முன்னாடி தான் இந்த லெவல் டிகிரீஸ் ஆயிருக்கு. அப்ப இந்த பாயிண்ட் வேணும் அப்படினா you have to select the past value at the same almost see if I am selecting omega t equal to 119.9999999 it is approximately equal to 120 only na. So we can select omega t equal to 120 just prior to this point. Let us see what happens. In this case Vm sin 120, okay, 120 minus 120 is going to be 0. This portion will become 0, right? Sin 120, right? Just now we saw, I think, right? Anyway, let me cross check once again. That is become root 3 by 2, right? That is 0.8666, right? So 0.866 அப்படினா மீனிங் என்ன? listen இங்க வேல்யூ எவ்வளவு இருக்கு? 1.732. here it is become 1.5. it is become what? 0.8666. I can say this value is 1.732 divided by 2 times of maximum voltage. Getting me? That is called 0.86666. அது எவ்வளவு? That is prior to this point. நீங்க ட்ரிகர் பண்றதுக்கு exactly 1 second or you can consider 0.0001 second க்கு முன்னாடி we are getting this one, and then suddenly there will be a spike. Again what will happen? Let us continue now. So again it will be decreased, again it will be raised, again it will be decreased, again it will be raised, again it will be decreased, again it will be raised, again it will be decreased, again it will be raised, again it will be decreased, and so on. Clear? அப்ப இங்கே waveform எப்படி இருக்கும்? It will be decreased, again it will be raised. Clear? That is how we are getting the waveform. I hope you all are getting. Still anyway, at alpha t equal to 30 also, we have what? Continuous conduction. Happy. Still we have continuous conduction only, there is no problem. Let us raise the value of alpha to 60 degree. Shall we check now? Yes. So this is at alpha t equal to 30 also I am getting continuous conduction. Do you have any discontinuous in the waveform? No. It is decreasing, rising, decreasing, rising, decreasing, rising, decreasing, rising. It's like a wave, but there is no discontinuity. Happy. Let us see. Raise the value of alpha to 60 degree. Let's see what happens. Shall I rub this one? You can do it by yourself. Anyway, session is being recorded, so you can rewatch. No issues. So let me run this one. Next, what we are going to do? Let us see. Now we have to remove these things because I am going to replace the switches. Right? If a switches நம்ம எங்க place பண்ண போறோம்? Your switches are going to be placed alpha equal to 60 degree. Right? So let us raise the value of alpha to 60. Let us draw the waveform for the next portion. Yes, omega t. Shall we start? Yes, let us start. But now I am raising the value of alpha to 60 degree. அப்படினா மீனிங் என்னங்க? If your alpha is being raised to 60 degree, if you want to draw the waveform, let us see. Once again, we know the on time of the thyristor will be deserved by omega t plus alpha only, right? But omega t is fixed as 30 degree plus now we are fixing alpha value as 60 degree such that first thyristor will going to be triggered at 90 degree. Do you agree? Exactly. Right? Let us draw. Yes. So first thyristor will going to be triggered at 90 degree. This is the position of the thyristor 1. So let us remove this one. Right? Thyristor T1 will going to be triggered here. 90 degree la first thyristor trigger பண்றீங்க அப்படினா from here let us remove all these people in order to avoid the confusions. Start பண்ணலாமா? Yes. So first thyristor will going to be triggered at 90 degree. After 60 90 plus 60 will become 150. So second thyristor will going to be triggered at thyristor T2 will be triggered at 150. Again from T2, right? After 60 degree 150 plus 60 will become 210. Exactly. At 210 we are going to trigger thyristor T3. Again from 210 after 60 we are going to get 270. Thyristor T4 will be triggered, and then from here after 60 T30 thyristor T4 will be triggered. Sorry, T5 thyristor T5 will be triggered. From here after 60 30 getting back after 60 in the sense here thyristor T6 will going to be triggered, and then 30 after 60 degree at T equal to 90 thyristor T1 will be triggered. We got the sequence. Yes. Now let us make the pulses in the sense in between T6 to T1. Anyway, first we are going to trigger thyristor T1. So T1 ல இருந்து நீங்க ஸ்டார்ட் பண்ணீங்க அப்படினா your journey in between T1 and T2 which trains are going to carry the passengers? Thyristor T6 and T1 will going to carry the passenger, and then T2 will become replace the even number. T6 will be replaced by T2 such that T1 and T2 will going to carry the passengers, and then after crossing T3 see there odd number will be replaced. 3 is an odd number, so old odd number will be replaced by new odd number, so it is become T2 and T3 will going to carry the passengers. After crossing T4, right, existing even number will be replaced such that T3 T4 will going to carry the passenger. After T5, right, this odd number will be replaced. T4, T5 will going to carry the passenger. Like that, again if you are getting back, T4, T5, right, they are continuing their connection, right? So there is T4, T5 only, but crossing, T6 se cross only immediately, T5, T6 will going to carry the passenger, and then T6, T1, and so on. This cycle will be continuous. Shall we draw the waveform? Yes. Let us slightly lift down the waveform, right? Axis, because I don't have space there. Let us draw. Start Lama. Yes. Anyway, our journey is from T1 only. Let us go from T1 itself. Where is T1? T6, T1. We are triggering the thyristor T1 and omega T equal to 90 degree, right? So let us start from here. Let us go ahead from here. First, நீங்க இந்த thyristor வந்து trigger பண்ணும்போது who are all in conduction? இப்போ நீங்க இத trigger பண்ணும்போது T6 and T1 will going to carry the passengers. Once again, T6, T1. That is T1 T6. T1 is upper leg phase A voltage, right? T6 lower leg phase B voltage. So we have to carry VA such that it can be written as Vm sin omega t once again minus Vm sin omega t minus 120 degree. Proceed பண்ணலாமா? Yes. Now anyway we are triggering the thyristor to what? Omega t equal to 90 degree, right? Yes. அப்ப replace பண்ணுங்க, just replace omega t by 90 degree. Just replace omega t by 90 degree such that sin 90 will become 1. So here we are getting Vm. Here 90 minus 120 will become minus 30. Sin of minus 30 will become minus sin 30. Already we have a minus, so minus into minus will become plus. Sin 30 will become 1 by 2. So Vm by 2 plus Vm will become 1.5 times of Vm. Yes. So initially we are getting 1.5. At this point we are getting 1.5. Right? Next, let us see what happens. Select intermediate point. In the sense, next thyristor will going to be triggered at T2, that is 150 only. I would like to know the value, intermediate value. For that I am selecting omega t equal to 120. Let us see, if I replace omega t equal to 120, omega t equal to 120, let's see what happens. Anyway, 120 minus 120 will become 0. Here 120 will become what? Just now we saw sin 120 equal to what? 0.866, right? That is root 3 by 2. So I understood at this point we are going to get 0.866. It will be reduced to 0.866 somewhere. So let us write this value is 0.866 in the sense root 3 by 2 times of Vm. Let us see. Next, when I am choosing at omega t equal to 150, let's see what happened at this point, right? Omega t equal to 150 in the sense we are going to trigger thyristor T1 and T2. Correct? Thyristor T1 and T2 in the sense, let's get up this one. Sorry, I learned that value also. Slowly understand, no problem, right? Start பண்ணலாமா? T1 T2 தானே? At omega t equal to 150 onwards, that is T1 and T2 are going to carry the passengers, right? So T1 T2, T1 T2, phase A, phase C. So it can be written as VAC. Answer is what? Vm sin omega t minus Vm sin omega t minus plus 120 degree, because VC, right? Yes. Start பண்ணலாமா? At which point we are triggering the thyristor at omega t equal to 150, right? So thyristor T2 will be triggered at omega t equal to 150 degree. So omega t will be replaced by 150. Estimate. Let's see. If I replace 150 here, once again it will become, right? I need of calcium for that. I don't remember this value. Do it by yourself. That is 1 by 2, right? Here it is 270 minus 1. So minus of minus become plus 1. Here we have 1 by 2, such that we are getting 1.5 times of Vm, right? So I am getting 1.5 times of Vmax. So value is 1.5. Again, did you notice that? Actually your value will be raised to 1.5, right? Again, it will be raised. Again, you might do wonder. If you want to know the value of least value, sir, value will decrease on 1.5 and then it is reduced to 0.86, and then again திரும்ப the decrease on suddenly lift ஆயிருக்குல. அப்ப நீங்க என்ன பண்ணனும்? If you want to know the prior to this point, anyway here your value will be hiked, right? Hiked to what? 1.5. If you want to know the prior to this, in the value க்கு just இதுக்கு முன்னாடி இருக்க வேல்யூ வந்து உங்களுக்கு தெரியணும் அப்படினா you can proceed. What shall we do? இதுக்கு முன்னாடி இருக்க சைக்கிள், இதுக்கு முன்னாடி அப்படிங்கிறது யாரு? Before triggering thyristor T2, T6 T1 was carrying the passengers. T6, T1 in the sense these two, VAB, right? So we have to estimate the value of VAB at omega t equal to exactly 150 degree. Prior to this point in the sense, it can be written Vm sin 150 minus Vm sin of 150 minus 120, because there is phase B voltage now. Estimate panna enna varum, it is become minus, sorry, it is plus 30, yes, sin 30, sin 30 is 1 by 2. Now Vm by 2, so we are getting what? Vm by 2, right? What about here? Sin 150 also 1 by 2 na? Yes, ipoda namu paatama irukku. I think anyway let us check 1 by 2 only, right? So this is Vm by 2. It is Vm by 2, we all know, right? So 1 by 2 minus 1 by 2 will become 0, right? Did you notice? Yes. அப்ப என்ன இருக்கு அப்படினா, this value has been reduced to 0, again there will be a hike, right? So let us continue. அப்ப ஒரு waveform நீங்க கண்டுபிடிச்சீங்க, அதே இடத்துல திரும்ப வரும். See there, அப்ப next என்ன வரும்? Intermediate point. Let us select 180. 150 ல we are triggering the thyristor. In between 150 and 210 we have an intermediate point, that is 180. அங்க value எவ்வளவு வரும்? Exactly we are going to get same 1 point, that is 0.866 only. And then we are going to trigger the next thyristor at 210. அப்ப அந்த டைம்ல என்ன ஆகும்? Again your value will be hiked to 1.5. Anyway, prior to this point we are touching 0. இப்போதான் நாம பார்த்தோம், right? I just now I given the that is proof for this. Actually this value will be reduced to 0 and then there will be a hike. Again it will reduce to 0 and then there will be a hike, right? Let us continue. At 240 we have an intermediate point, so value will be reduced to 0.866. Again at 270 we are triggering the thyristor, value will be hiked to 1.5. Again let us continue our journey, and then at 330 that is intermediate point, value will be reduced to 0.866. At 330 here there will be a hike in the waveform. Again at 360 your value will be reduced, and then there will be again reduced to 0, and then there will be a hike. You can getting back, you can got back here, that is your value. அப்ப இங்க என்ன வரும்? இங்க reduce ஆகிற value, right? அங்க இருந்து இங்க 0 வரும். இங்க see that this point, இந்த point 360 க்கு அப்புறம் getting back 360 will be, it has to be reduced to 0. Again we are triggering thyristor, T6 will be triggered here, right? So there will be a hike in the value. Again intermediate point 60 degree it will be reduced, and then will be touching 0, and then T6 again there will be a hike, again reduced to 0, and then hike, it will be continuous. Waveform variyalama? Yes. Let us draw the waveform, right? Let me start from here. First 1.5 reduced to 0.866, again reduced to 0, right? 0 cross but again there will be a hike, right? Again it will be reduced to 0, again there will be a hike, again it is being reduced to 0, again there will be a hike, again it is being reduced to 0, again there will be a hike, again it is being reduced here. Anyway it is going continuously, and the waveform நம்ம இங்க வரைஞ்சிக்கலாம் remaining portion, right? Because அது 390 போது நான் 360 ஓட டிரா பண்ணி பேக்ல வந்துட்டேன், right? So again there will be a hike, again it will be reduced to 0, again there will be a hike, again it will be reduced to 0. How many pulses are there? 1 2 3 4 5 6. Getting this small portion is being reflected here over 360 degree, right? Because we are considering only 360 degree, na? Yes. So did you notice at alpha equal to 60 degree we are touching the boundary in the sense, till now I did not get discontinuous. So here also I am not getting discontinuous, but I am touching the boundary in the sense almost we are touching 0. Ball on the bounce ஆகுது, right? 0 ground point போய் reach பண்ணுது, but immediately there will be a hike, right? Again it will be pushed back, right? Pushed back to the height, right? So when now it is decreasing, again pushed back, but it is not 0 வரல, level ஓட வேல்யூ. இந்த வாட்டர் லெவல்ல பாத்தீங்கன்னா லைக் இந்த மேரேஜ் காலுக்கு முன்னாடி எல்லாம் வச்சிருப்பாங்க, வாட்டர் லெவல் is keep on rising, sprinkling water pump will be there, right? You can observe that one. Water level it is rising, decreasing, right? So if I keep a ball there, then what will happen? Like that you can observe, right? So your value ball is reducing, but it is not touching, right? And the கீழ இருக்க ball வந்து டச் பண்ணாது, right? Again it will be raised, again it is decreasing, but there is no discontinuity in the sense it has to touch the ground for some portion, for some time period there is no water level, எதுமே இருக்க கூடாது, ball again நிக்கணும், that is discontinuous. Again it will be reduced, raised, again it is 0, discontinuous. But till now I am not getting discontinuous, but I am touching the boundary of the discontinuity. So alpha equal to 60 degree is the boundary point, right? So conclusion, if you want to get the continuous conduction, இப்போ எனக்கு என்ன ஆகும்னா பவுண்டரி வரும், எப்படி வரும் அப்படின்னா see I may have the pulses, water level என்ன ஆகும், decrease raise. I need a periodic waveform, right? I don't want to get any discontinuity, right? So that is called a continuous, right? So level is decreasing, raising. but I am in need of continuous convection. That could be possible when the value of alpha is less than 60 degree. If I make the value of alpha equal to 60, we are touching the boundary of the what? Marginality, right? Boundary of the discontinuity. Correct? So see there. Alpha equal to 60 வரும்போது நம்ம 0 கிராஸ் பண்ணியாச்சு. திரும்பவும் நீங்க ரேஸ் பண்ணீங்க அப்படின்னா automatically discontinuity will fall in place. Let me explain. Don't be panic. Anyway, I understood one thing. What I understood? If you want to make continuous convection, then the value of alpha should be less than 60 degree. Restriction is given now. Whereas when I was discussing about the three-phase half-wave rectifier, what we saw, alpha should be what? Less than 30 degree. That is for three-phase half-wave rectifier. Whereas for full-wave rectifier, the value of alpha should be restricted to less than 60 degree. Right? So let us make the next statement. For the continuous convection mode, value of alpha should be restricted to less than 60 degree. That's all. Alpha value should be less than 60 degree for continuous convection. If the value of alpha equal to 60, that is called boundary of discontinuity and continuity. Either you can consider one thing, right? That is the boundary of continuity and discontinuity. Clear? Next if the value of alpha is it will become greater than 60, then that is called discontinuous convection. Let me prove it, don't be panic. Make these statements. That is what I want. See, you will be tested for some worthless questions in your future, right? Just one more question. The TRBT enable apdi da kepanga. Three-phase full-wave rectifier discontinuous connection, the range of the alpha is what? For continuous connection, what is the range of alpha? Margin of continuity and discontinuity is what is the value of alpha? You can simply keep your answer if you remember, right? Silly questions. But you have to understand, right? You have to understand. Then only these things will be registered into your brain. That's very important, right? Getting back. Now, what is the target? Shall we moving on to the next one? Raise the value of alpha to 60, 75, 90. Keep 90, right? Let's make it possible, right? Some high value of discontinuity. Keep alpha equal to 90. Let us make it possible. Omega t. I am raising the value of alpha to 90 degree. Let's see what happened. Okay. Actually, I have to rub this one. We have to make the new sequence. Do it by yourself. Happily, you can do it now. I hope you all have understand these things now clearly. So you no need to wait for me. Do it by yourself. Let us start. Start along. What is the value of alpha? Anyway, initial t on is depending on the value of omega t plus alpha. We all know omega t is 30 degree. What of the value of alpha? We are in height now, right? So our peak value of alpha, right? Almost we are touching alpha equal to 90 degree. Happily, right? If alpha will become 90, then the starting first thyristor will be triggered at omega t equal to 120. Right? We are getting far away from the initial point. Whereas this is the point we are going to trigger the first thyristor. Let us make it possible, right? Thyristor T1 will be triggered here. Immediately after 60 degree, thyristor T2 will be triggered, right? So let us see. At omega t equal to 120, sorry 180, thyristor T2 will going to be triggered. Again, from here after 60 degree at 240, thyristor T3 will going to be triggered. Again from 240 after 60 degree at 300, thyristor T4 will going to be triggered. Immediately from 300 after 60 at 360, they are going to trigger thyristor T5. Is it correct? T1, T2, T3, T4, T5 will be triggered. After 360, getting back at 60 degree, thyristor T6 will be triggered. Again from here after 60 at 120 degree, thyristor T1 will be triggered and so on. Clear? Yes. Shall we make the train pulse now? Which train will going to carry the passengers? Now in between T1 and T2, T6 and T1 will going to carry the passengers. And then simultaneously we can write T1, T2 will going to carry the passengers, and then T2, T3 will going to carry the passengers, and then T3, T4 will going to carry the passengers, and then T4, T5 will going to carry the passengers, T4, T5 will going to carry the passengers, and then T5, T6 will going to carry the passengers, and then again T6, T1, and so on. This cycle is being repeated. It's periodicity. Shall we draw the waveform? Of course, let's start. Engine start பண்ணலாம். Anyway, our journey is from T1. Let's go. Our area is completely freezed. In the degree minus. Okay, let us start. We are going to start our journey from omega t equal to 120. This is the point, right? We are going to start our journey. Start playing. T1, T6 will going to carry the passengers, right? So T1, T6. T1, T6. T1 positive voltage, T6 negative voltage. Away from another, it can be written as VAB. Write the answer. Do it by yourself. Please don't wait for me. Don't look at the board. Because anyway I am going to draw the one, right? Whether the thing is you have understand these things or not. Do it by yourself, right? Blindly, right? Do it. Whichever the things that you have understood, just apply it. So try to draw the waveform completely, and then watch the lecture. Because the thing is you have to understand, right? Listening to the lecture won't help you. Substitute பண்ணலாமா? Where are we now? We are standing at omega t equal to 120, right? Let us do it. Make it possible at omega t equal to 120. Let us observe the waveform. Omega t equal to 120, right? Such that 120 minus 120 will become 0. Sin 120 is what? Let us see. Sin 120 is going to be once again root 3 by 2, right? So root 3 by 2 times of Vm. That is sin 120. So where is sin 120? This one somewhere. Let me place that value somewhere here. Root 3 by 2 times of Vm, right? That is 0.866. That is what I am getting at sin 120. Let us see at sin 150 what I am going to get. At sin 150 same value, but we are going to replace, change the angle, because in between 120 and 180 T6 and T1 are going to carry the information, passengers, right? They are going to carry the passengers such that T6 T1. This is my T1, this is my T6. Let us do it. Second case, what I am going to get? 150, right? Let's make it possible. 150 if I take sin, I am getting 1 by 2, right? Such that it is become Vm by 2. Again, if I will replace it by 150, 150 minus 120 will become, so I am getting 0, right? I understood. I am getting 0 because what happened here? 150 minus 120 will become 30. Sin 30 will become 1 by 2. So minus 1 by 2 plus 1 by 2 will going to be 0. Minus 1 by 2 plus 1 by 2. Vm by 2 minus Vm by 2 will become equal to 0, right? So we are going to get 0. Here it is going to be root 3 by 2, right? It's over. Next, at 180 what happens? If I consider, right, see, at 180 what we are going to do? At 180 we are triggering the next thyristor. Which thyristor? Thyristor T3 will be triggered. Such that we will have to change the people now, because not people, train will be changed, right? So we are going to change the train. T6 will be stopped, right, at the junction T2. Now T2 and T1 will going to carry the passengers from 180 onwards, right? So T1 VA, T2 VC, so VAC, it can be written as Vm sin omega t minus Vm sin omega t. Let's this plus 120 now. Yes. Let us see the value at omega t equal to 180. 180 is correct? Yes, we are at 180. Sin 180. Let's see sin 180. What happened? Next, here also we are going to consider 180 only, right? Such that if I reduce this value, we all know sin 180 equal to 0. I hope you all remember, right? Similarly, if I add this value, I am getting 300. Let us see at 300 what I am getting, minus root 3 by 2. So already we have one more minus root 3 by 2, so it will become plus root 3 by 2, right? Times of Vm. Again I am getting Vm, right? Let's see next what happened. Actually, what we have done here, did you notice all these things here? Anyway, wait. Let me do it. Let us continue. After this point, again I am getting, right? So here we are getting once again. Happily, let me do one thing. Let me raise the level of height of the system. Let us go with this one, right? It is going to be root 3 by 2 times of Vm, because we are getting discontinuity. So here I am getting this one, and then we got 0 at the intermediate point. We got 0 again, it will be raised to root 3 by 2 again. இதுக்கப்புறம் நீங்க திரும்ப வரைஞ்சிக்கலாம். அப்ப திரும்ப இங்க என்ன வரும்? It will become 0 again, it will be raised here again, it will become 0 again, it will be raised here again, it will become 0 again, it will be raised here again, getting back, it will become 0 again, it will be raised here again, it will become 0 again, it will be raised here, right? So that is the intermediate point, right? So what do I understood here? The thing is, if you notice this waveform carefully, we are standing here reaching 0 discontinuous, right? Listen sir, inga discontinuous da varanuma appdi neenga enna kettingna, it is not necessary. Na complete waveform varayanuma, right? If you want to know the value, ipa na enna solra appadina, ipa continuous connection eduthikalam. Enakku indha edathila continue agudhu appadina, I would like to know the negative value. Ipa indha edathila T6 T1 turn on பண்ணதுக்கு முன்னாடி இங்க யார் ஆன்ல இருக்கா? T5 T6 கரெக்ட்டா? Exactly just before turning on thyristor T1, prior to this point, passenger trains T5 T6 are going to carry the passengers. So during this journey, in this journey, immediate, that is prior to this point, omega equal to 120 degree க்கு ஒரு செகண்டுக்கு முன்னாடி என்ன வேல்யூ இருக்கு செக் பண்ணி பார்க்கலாமா? Let's see. Let me rub this one. Let us estimate the value. In continuous conduction யாருக்கு வரும்? Discontinuous conduction will become for resistor. If you have inductor load, then inductor will free wheels and it will push the thyristor to continuous its conduction even in negative voltage also. So negative spike will exist when we will have inductive type of loads. Let us continue, right? I don't want to draw the discontinuous right now. Let me completely draw the waveform and then we will remove the negative spikes by considering resistive load. Clear? Let's see. Now prior to this point, just before T61 க்கு முன்னாடி யார் இருக்கா அப்படினா T5 T6. T5 இங்க இருக்கு, T6 இங்க இருக்கு. T5 in the sense phase C positive, T6 phase B negative, such that it can be written as BCB. BCB that is Vm sin omega t plus 120 minus Vm sin omega t minus 120. Let us estimate this value now. எங்க நம்ம கால்குலேட் பண்ண போறோம்? omega t equal to 120 exactly, right? இப்போ replace பண்ணீங்கன்னா replace omega t equal to 120, here also replace omega t equal to 120 such that this portion will become completely zero. What about this portion? Let us see. Sin 240 ஓட வேல்யூ எவ்வளவு செக் பண்ணுங்க. 240 க்கு we have to, sorry, I made mistake here. 240 we should take minus root 3 by 2 times of Vm, right? So I am getting minus root 3 by 2 times of Vm. What we have understood here? So the waveform will become like this. It will be reduced here and will be, it is reaching, right? Negatively there will be a hike, and then again it is rising here. Again it will be reduced. And so on, right? Okay. Sorry. Yes, that is the actual waveform at alpha equal to 90 degree. But this negative waveform could be possible if I have RL load. Exactly, inductive type of load. If you have inductive type of load, then happily we can let the negative spike also to appear at the output port. Suppose if you don't have the negative spike, then what will I do? I cannot go beyond this. See there, if it is the resistive load, right, we are triggering the thyristor at நம்ம எங்க trigger பண்ணுவோம்? Thyristor T1 is being triggered at 120, right, and it will be continuous. எது வரைக்கும் போயிருக்கு பாருங்க, 180. It will go up to 180, right? So actually we are triggering the next thyristor at 180, right? So it will go up to 150. 150 க்கு அப்புறம் என்ன இருக்கு பாருங்க, we are getting discontinuous conduction. See that this thyristor T1 will go up to 150 degree. அதுக்கப்புறம் என்ன இருக்கு பாருங்க, if it is a resistive load, right, if it is a resistive load, then thyristor T1 will continue its conduction happily up to omega t equal to 150 degree only. After that, immediately after 150 degree, the voltage level is being, see there, did you notice these things? See there, after 150 degree என்ன ஆகுது அப்படினா, here I am getting negative voltage. If I am getting negative voltage after 150 degree, can you let your thyristor to continue its conduction? No. Voltage is being reversed. Voltage வந்து reverse ஆயிடுச்சு அப்படினா, then what will happen? Immediately the thyristor will be forced to turn off. If it is the resistive load, suppose inductive load இருந்தது அப்படினா, this much amount of positive energy will be stored across the load side of the inductor. That positive energy will become, அப்ப என்ன ஆகும், சப்ளைல வந்து polarity reverse ஆகும்போது load side ல store ஆயிருக்க positive energy is more than the value of energy, negative energy offered by the supply. சப்ளை இருந்து வர நெகட்டிவ் எனர்ஜி விட இண்டக்டர்ல ஸ்டோர் ஆயிருக்க எனர்ஜி வந்து அதிகமா இருக்கும். எப்போ வந்து சப்ளை வந்து இமிடியேட்டா ரிவர்ஸ் ஆகுதோ அப்ப அந்த டைம்ல என்ன நடக்கும் அப்படின்னா, that positive energy that was being stored across the inductor will push the thyristor to continue its conduction until the arrival of the next thyristor. அடுத்த thyristor உள்ள என்டர் ஆகுற வரைக்கும் this energy will free wheels. Your energy is getting back to source and through the thyristor some energy is being dissipated through the resistor. So continuous, that is what I told you. Even in half-wave rectifier, three-phase half-wave rectifier also, what we saw, if you have inductive nature of the load, current strip type of loads irundhathu appadina, you no need to be bothered. You know continuous connection always. In such a case, I no need to define the range of alpha. If you have always, if your load is always current strip type of load, then there is no point of discussing about alpha range. If I have resistive type of load or voltage strip type of load, I will have to bother about the value of the, what I can say, firing angle. Whether the firing angle is less than 60 degree or it is equal to 60 degree or it is greater than 60 degree. Based on the values of the firing angle, you may get continuous conduction mode or discontinuous conduction mode, or you may touch the boundary of the continuous or discontinuous. So these things that are could be possible, or these things that are we need to discuss when there will be a voltage strip type of load is being connected at the output port. Clear? Yes. I hope now you are getting a clear idea. So let me repeat once again. Continuous conduction அப்படினா current strip type of loads க்கு எப்பவுமே continuous conduction தான். Whichever things that we saw in half-wave rectifier, same thing is being repeated. But when I am looking for resistive type of loads, resistor வந்து எனர்ஜியை ஸ்டோர் பண்ண போறது கிடையாது. அப்ப சப்ளை வோல்டேஜ் ரிவர்ஸ் ஆச்சு அப்படினா தைரிஸ்டர் ஆஃப் ஆயிடும், அவ்வளவுதான். ஏன்னா ரெசிஸ்டர் வந்து எனர்ஜி ஸ்டோர் பண்ணி அந்த எனர்ஜியை வச்சுக்கிட்டு நம்ம போயிட்டு we are not going to push any thyristor to continuous conduction, right? That things we know. So what is the conclusion here? At alpha equal to 90 degree, if you have current strip type of load, then this is the waveform. Suppose கீழ அப்படியே axis extend பண்ணுங்க. If you have voltage strip type of load, voltage strip in the sense negative spike will be disappear, or load negative spike will be disappear, you will never have negative spike. This is the waveform for R load. கீழ ஒரே waveformல வரைஞ்சிராதீங்க, நீட்டா வரைங்க, தனித்தனியா கீழ இன்னொரு first current strip type of load will have continuous conduction. There is no point is called discontinuous conduction அப்படிங்கற வேர்டே கிடையாது. எதுல current strip type of load with a large value of inductance, right? So the conclusion is what? Resistive load வரும்போது we are getting discontinuity when the value of alpha will become greater than the value of 60 degree. அவ்வளவுதான். Alpha value 60 விட அதிகமா போயிடுச்சுனா we are getting discontinuous conduction. What is our next target? Now if you don't know next, அப்ப இதுல range of alpha என்ன வரும் அப்படினா, in this case when the value of alpha greater than 60 degree, then in order to estimate the value of average value, we should raise அப்ப omega t ஓட boundary வந்து என்ன அப்படினா, for above greater than 60 for resistive load we can go from alpha plus 30 degree. alpha plus 30 ல நீங்க ஸ்டார்ட் பண்ணிட்டு alpha plus 30 னா இப்போ நம்ம என்ன பண்ணிருக்கோம், we are keeping alpha equal to 60 above 60 னா இங்க alpha க்கு 90 degree போட்டேன். So we are starting at 120 degree. So that will be divided by alpha plus 30 point. But maximum point எவ்வளவுங்க? Listen, starting point வந்து it is starting point of the thyristor is depending on the value of alpha, whether it is 0 or 10 degree 30 degree 40 degree. alpha க்கு நீங்க எந்த வேல்யூ கொடுக்கறீங்களோ அத பொறுத்து தான் starting point இருக்கும். But what about the ending point? alpha க்கு நான் 90 degree கொடுத்தேன். alpha க்கு 90 degree கொடுத்தீங்கன்னா we can go up to 180. Are we reaching 180? No, we are stopping our conduction up to, that is 150 நீங்க ஸ்டாப் ஆயிட்டீங்க. So what is the conclusion? In case of discontinuous conduction, that is when the value of alpha is greater than 60 degree, right? When independently, that is independent the value of alpha, right? அதாவது ending point of the thyristor ஓட conduction point வந்து எந்த இடத்துல end ஆயிடும் அப்படினா, it will be stopped, right? Its conduction will be stopped exactly at omega t equal to 150 degree. நீங்க alpha வந்து என்ன வேல்யூ போடுங்க, நீங்க 65 போடுங்க, 68 70 75 78 80 90 110 120 என்ன வேல்யூ போட்டாலும் சரி, thyristor என்ன பண்ணாது, 150 டிகிரி தான். என்னால அதுக்கு மேல வர முடியாது. ஏன்னா இங்க ஒரு சப்ளை நீங்க ரிவர்ஸ் பண்ணீங்கனா கண்டக்ஷன் பண்ண முடியாது. it will turn off. என்னால பண்ண முடியாது, நான் பண்ண மாட்டேன்னு சொல்ல, என்னால பண்ண முடியாது. I will be turned off, right? Because polarity supply வந்து ரிவர்ஸ் ஆகுது. எனக்கு நான் வர்க் ஆகணும்னா எனக்கு ரெண்டு கண்டிஷன் satisfy ஆகணும். நீங்க கேட் பல்ஸ் கொடுத்துட்டே இருக்கீங்க, I am really very happy, but another condition is invalid. Voltage across the anode will become less than the value of voltage across the cathode now, so I cannot turn on. That messages we are getting from the thyristor. So what will you do? Okay, just go and turn off. So the conclusion is The maximum boundary point is only 150 degree. We cannot go beyond this one. Average you calculate பண்ணும்போது you have to use this range. Clear? Yes. I hope you all are getting a clear idea. Shall we start? Right now we have to estimate the values, right? So we saw two type of boundary. Continuous connection க்கு boundary என்ன 30 plus alpha to 90 plus alpha. That is for continuous connection. For discontinuous connection boundary is what? 30 plus alpha to 150 degree. That's all. This is all about three phase full wave rectifier. Do you have any problem here? What's wrong? Nothing is there to understand. Yes. Okay, let me rub this thing. Okay, just we will keep it. Now I think this diagram is don't want. We will remove this one. Let us estimate the values. Right? V0 average calculate பண்ணலாமா? Let's start. V0 average அப்படிங்கிறது there are two type of connection we saw. One is continuous connection, another one is discontinuous connection. But continuous connection current strip type of load எப்பவுமே continuous தான். Yes or no? Current strip அதாவது inductive type of load வந்து எப்பவுமே continuous தான். So இப்போ நம்ம first என்ன பண்ண போறோம்னா we are going to talk about continuous connection. Anyway இங்க continuous connectionல நமக்கு ஜெனரலா என்ன ஃபார்முலா வருதோ that formula is common for RL load. RL load that is the one and only formula. But if you have resistive load, right? So continuous connection we are going to keep two people. One is R load, RL load. RL load inga neenga calculate panna formula general formula. But whereas for resistor continuous connection enga possible when the value of alpha less than 60 degree. Shall we estimate? Let us go ahead. We have to understand one more thing. நம்ம என்ன waveform ல வரைந்திருக்கோம், whether we have drawn the waveform for line of phase, line voltage. We have drawn all things for line voltage. Why? We know நம்ம எல்லாமே என்ன பார்த்தோம், VA minus VB, VB minus VC, VC minus VA அப்படி தான போடுவீங்க. அப்ப எல்லாமே line voltage தானே? Yes. So you have to do these things. Okay, period first check பண்ணுங்க. What is the period of this cycle? One period. Actually we are getting 3 pulses. Sorry, we are getting 6 pulses, right? 6 pulses அப்படினா over a cycle 360 degree குள்ள 6 pulse வந்திருக்கு. Now what is the period of one pulse? It is going to be what? Just cancel it by 60 degree. Is ready to convert பண்ணுங்க. Pi by 180. Right? It will become did I do it? Yes, it is become 6 times of 60, right? So what I have to do? We have to convert. How many pulse we are getting? Totally I am getting 6 pulse. Right? அப்ப 6 pulse வந்திருக்கு அப்படினா its period is what? Totally we are going to carry. மொத்தமா வந்து 360 degree, right? அப்ப one pulse periodicity of one cycle. We have to consider only one cycle periodicity, right? So let us see. Wait a minute. Okay. Is it correct? Is it going good? We have to draw. Okay, wait a minute. Let me cancel it. That is going to be pi by 3. Pi by 3 அப்படினா how many cycles will be there? Pi by 3 in the sense we are getting 60, right? Is it correct? That is 180 by 3. We are going to 180 na 60 degree. 60 60 we are going to get 6 pulses, right? Yes. Okay, fine. Now anyway I am going to estimate the area of V0 average, right? அப்ப V0 average வேணும் அப்படினா how many periods we are going to consider? That is how many periodicity we are going to consider? We are going to consider totally 6 periodicity, right? Sorry, periodic cycle. அப்ப 6 pulses இருக்கு அப்படினா see it is like this. Periodicity in the sense after a particular time period nature of the cycle is going to be repeated. Again it is going to be repeated. அப்ப நீங்க என்ன பண்ணுவீங்க? Only one cycle we can consider. We don't need to consider all cycle. ஒரு cycle period எவ்வளோ? We are going to consider only 60 degree for a cycle, right? We are going to consider only 60 degree for a cycle. So period of a cycle is 1 upon pi by 3. Totally we are going to get 6 pi's, that is 6 pulses, such that 6 into 60 will become 360, right? Yes or no? Yes. So with this let us go ahead. Let me rub this next now. First I know in case of if alpha is less than 60 degree, then your conduction is you can start from alpha plus 30 or 30 plus alpha to alpha plus 90 or 90 plus alpha, and we are going to consider maximum line voltage. Don't forget we are in line voltage. Line voltage எப்படிங்க எழுதுங்க? Sin of omega t plus 30 degree. Do you remember? Yesterday what I have done? Just revise your notes. If you are considering line voltage, since we are keeping star connected network, in case of star connected network, line voltage will always leads our phase voltage by an amount of 30 degrees. So line voltage being represented as sin omega t plus 30. This plus 30 denotes there will be a leading in the line voltage from phase voltage. Clear? Yes. Let us go ahead. Okay, this is for discontinuous connection. Start பண்ணலாமா? Yes. Denominator will be numerator such that it will become 3 by 5. You can take maximum line voltage outside. Sin omega t integrate பண்ணீங்கன்னா we are going to get minus cos omega t plus 30 degree exactly, and your limits are going to be, see, lower limit is alpha plus 30, upper limit is alpha plus 90, right? Anyway, here we don't have space, so let us remove this discontinuous portion. I don't want this one, right? Let's remove this portion. Anyway, this also I don't want. Let us estimate the value. Start பண்ணலாமா? Yes, அப்படியே கண்டிப்பா பண்ணுங்க. It can be written as 3 times of maximum line voltage by 5, right? In bracket you have minus. If you want to take that minus outside, first for time being, now I will keep it outside, later we will see. Limits substitute பண்ணுங்க, it is become cos of, see there, omega t is going to be replaced by alpha plus 90 such that it will become alpha plus, already we have 30 plus 90 will become 120, so cos of alpha plus 120. Lower limit minus, see already I took this minus outside, right? So lower limit substitute பண்ணீங்கன்னா cos of alpha plus omega t will be replaced by alpha plus 30, already we have one more 30 na, such that it will become alpha plus 60 degree. Let us extend this value such that it is become, in the next step, minus 3 times of maximum line voltage by 5 in bracket cos a plus b. What is the formula? Cos a cos b minus sin a sin b, it is over, right? Minus of cos a plus b, once again cos a cos b minus sin a sin b. Okay, yes, let us go ahead. Next step, apply values substitute பண்ணிடலாமா? What is the value of cos 120? Let me keep calculate me. 120 cos, I am getting minus 1 by 2. For this I am getting minus 1 by 2. Better to keep this one. Yes, let me do one thing. This is going to be minus 1 by 2, right? And then second value sin 120, let's take sin, that is become root 3 by 2. Similarly, cos 60 we know that is 1 by 2. Anyway, let us check sin 60, that is root 3 by 2 only na. This is going to be root 3 by 2. Reduce பண்ணலாமா? இது யாரா கேன்சல் ஆகறாங்களா பாருங்க. See, is the term is getting cancelled. So here it is become what? This is, yeah. See, minus sin alpha into root 3 by 2. இப்போ இந்த மைனஸ் உள்ள பாஸ் பண்ணுங்க. Minus of minus, right? It will become what? Minus of minus will become plus. So plus sin alpha, that is plus sin alpha into root 3 by 2 minus sin alpha root 3 by 2. These two terms are getting cancelled, right? Now let us see. If in the minus உள்ள பாஸ் பண்ணீங்க அப்படினா what I will get? Minus cos alpha into 60 degree, right? So இங்க எனக்கு இன்னொரு minus 1 by 2 வந்திருக்கு பாருங்க. See, carefully notice. சார் அப்ப இவங்க ரெண்டு பேரும் கேன்சல் ஆக மாட்டாங்கனா ஆக மாட்டாங்க. ஏன்னா இங்க மைனஸ் இருக்கு பாருங்க. இதோட நெட் வேல்யூ minus 1 by 2. So minus cos alpha by 2. Here I am getting minus cos alpha by 2. Here also I am getting minus cos alpha by 2. Such that minus cos alpha by 2 minus cos alpha by 2 will become cos alpha by, that is 2 times of cos alpha by 2, or I can say cos alpha. Correct? So this net value should be equal to, this total value should be equal to cos alpha. Simply we can remove this all things. I can write the answer directly, right? See there, here we have minus, இங்க ஒரு minus இருக்கா, இந்த minus உள்ள பாஸ் பண்ணுங்க. அதுக்கு முன்னாடி இது வந்து இங்க minus 1 by 2 into cos alpha, இந்த minus உள்ள பாஸ் பண்ணீங்கன்னா minus 1 by 2 into cos alpha, minus cos alpha by minus cos alpha by 2 minus cos alpha by 2 will become what? Minus cos alpha. We have one more minus na, so net value என்ன வரும்? Plus cos alpha. That's all. Remove all these things, write the answer directly. So this term will become equal to the value of cos alpha. What is the difference between this one and the previous case? இதே continuous conduction க்கு 3 phase half wave rectifier நம்ம என்ன பார்த்தோம்? Do you remember? 3, I think that value will become 3 by 2 pi, right? That is 3 times of VML by 2 pi into cos alpha, correct? நோட்ஸ் ரிவைஸ் பண்ணி பாருங்க. அங்க இங்க டினாமினேட்டர் 2 இருக்கு, இங்க இல்ல. ஏன்? இது வந்து full 6 pulse, அது 3 pulse, double ஆயிருக்கு voltage. So what is the conclusion? In continuous conduction mode, I can say, right? So in continuous conduction mode, V naught average, right? V naught average of 3 phase full wave rectifier, right? So this is 3 phase full wave rectifier should be equal to twice of V naught average of what is this? 3 phase half wave rectifier in continuous conduction mode. Note the thing, in continuous conduction mode. We are in continuous conduction mode only now. So in continuous conduction mode, that is the answer. Clear? So now keep one more thing in your mind. This is the common formula for RL load. Inductive load பொறுத்த வரைக்கும் this is the one and only formula that we are going to use for entire value of alpha. Now keep the note. தனித்தனியா எழுதுங்க, right? For resistive load, if the value of alpha less than 60, then this is the formula. For the same resistive load, if the value of alpha greater than 60, let us see. But இன்னொரு வேலை தனியா கீழ நோட் போட்டு எழுதிங்க, right? For current strip type of load, right? Or for inductive type of loads, the generalized formula for all range of alpha is 3 times of VML by pi into cos alpha only. Clear? Yes. Now what is our next target? We have to estimate the value of V naught average for discontinuous conduction, right? So let us see. Let me rub this one. Yes. Let us talk about discontinuous conduction. So when I am looking for discontinuous conduction, alpha is what? Alpha become greater than 60 degree, right? If alpha is greater than 60 degree, it is only for resistive type of load, that is voltage strip type of loads. Clear? Yes. So in voltage strip type of load, what they are going to say anyway, if you want to estimate the value of V naught average, we all know anyway the period is what? 1 by pi by 3 only. But we are going to travel from initial value is alpha plus 30 and 30 plus alpha, but maximum value should be restricted to 150. We cannot go beyond 150. Just now I have given proof, right? So it can be written as once again maximum line voltage into sine of omega t plus 30 degree. It is leading your phase voltage. That's why I am considering that 30. Don't be panic. Just reduce the function. Shall we continue? Yes. Let us proceed. 3 by pi, right? VML you can take it out. Integration of sin omega t will become minus cos omega t plus 30. Let us go ahead. Limits are going from alpha plus 30 to 150. Start பண்ணலாமா? Yes. In the next step, if you want to take minus also, you can take. So such that it will become 3 times of VML by pi in bracket cos of upper limit. Omega t will be replaced by 150. So 150 plus 30 will become 180. First one, right? Let us go ahead. Minus cos of alpha is omega t will be replaced by alpha. So that is become alpha plus 60 degree. Just we can stop with this, right? That is enough. I am not going to extend this values. Directly we can substitute. If you open up the brackets, if in the minus உள்ள பாஸ் பண்ணுங்க, cos 180 equal to what? Minus 1. Already we have one more minus, so minus into minus will become plus. அதே மாதிரி இந்த minus உள்ள பாஸ் பண்ணுங்க, this is also will become plus, such that your answer will become 3 times of maximum line voltage divided by pi, right, into in bracket cos 180 will give you 1 minus 1. Here I have one more minus, such that this become plus 1. Here also I am going to get plus only. Here we have minus, but here we have minus. Minus into minus will become plus. So 1 plus cos of. Hello, that is over. See, you don't memorize anything. How many steps that we are taking here? Is there any point of memorizing these things? No. Is there any point of wondering? See, for இப்போ நீங்க compare பண்ணுங்க, half single phase rectifier 3 phase கூட compare பண்ணா, which is the very easy. Easy in the sense, I am not telling in the direct point of view. Direct point of view, all are easy only. But analyzing these things, it will take only some 30 to 40 minutes to understand, right? For that we have to spend separate time. ஒவ்வொரு இதுக்கு நம்ம எல்லாத்தையும் direct பண்ணணும். In case of single phase, but in 3 phase the beauty is one step we can do all things. It's over. Clear? So this is only for voltage shift type of load. So don't forget this procedure that I am giving. You don't need to memorize, but you have to remember the procedure. Yes, clear? So that is how we are estimating V naught average here. Next, we have to find out the value of, right? So let me rub these things. I said we have to calculate the value of average value of the thyristor current, RMS value of the thyristor current. Clear? So let me do it, right? With this, இந்த நான் என்ன procedure follow பண்ணனும் அதை வச்சு நீங்க அங்க போட்டுக்கலாம். யாருக்கு 3 phase half wave rectifier, right? Anyway, at last I will make one tabular column and I will give it to you. Just use it for future reference, right? I have written all the formulas in a separate note in forward runnings when I was preparing for my exam, right? So I will give that one to you. Later you can keep it with you, right? Okay, listen. Actually, in this three phase of a rectifier, sorry, we are in full wave rectifier, right? In full wave rectifier, I would like to know the average value of the thyristor current, right? For that, take any one thyristor, one leg. Take any one leg. That is one phase. Either you can consider phase A or phase B or phase C. That's one leg. Let us estimate first. Because I am in of source current also as well as thyristor current also. For that I am taking one leg. Later I will take it, don't be panic. Now one leg mattu eduthuka. This thyristor T1, this is thyristor T2, T6, T4. Clear? Yes. This is phase A. Here I will inject phase A anyway. This is for positive voltage, this is for negative voltage. Right? Yes, we know. Shall we estimate? Yes. Now enna parunga anyway. What is the period of each and every thyristor? Each and every thyristor will conduct for the period of 120 degree. Do you agree? Over thyristor 120 degree வந்து conduction நடந்துரும். Some of you are having the doubt here. Sir, நீங்க 60 டிகிரிக்கு ஒருத்தர் வந்து ஸ்விட்ச் பண்றீங்களா, ட்ரிகர் பண்றீங்களா, அப்ப 60 டிகிரி தான வரும். ஏன் 60 டிகிரி வரணும்? நான் என்ன சொல்லுவேன்? தைரிஸ்டர் வந்து இப்ப தைரிஸ்டர் T1 வந்து நீங்க 60 டிகிரில ட்ரிகர் பண்றீங்கன்னா அடுத்த 60 டிகிரிக்கு அப்புறம் அடுத்த தைரிஸ்டர் நீங்க ட்ரிகர் பண்ணுங்க தான் நான் சொல்றேனே தவிர நீங்க ஒரு தைரிஸ்டர் ட்ரிகர் பண்றீங்கன்னா அது 60 டிகிரி மட்டும் தான் ஆன்ல இருக்கும். அதுக்கு அப்புறம் இன்னொரு தைரிஸ்டர் ஆன் ஆகும்போது முன்னாடி ஆன்ல இருந்த தைரிஸ்டர் ஆஃப் ஆயிடும் நான் சொல்றேன். Each and every pulse will be carried by a pair of thyristor. If you notice the things carefully, see that நம்ம sequence எப்படி பார்த்தோம்? First I took T6 T1 and then see that T1 T2 and then T2 T3 and so on. If you notice, see that T1 பாருங்க, each and every pair will going to ஒவ்வொரு pair வந்து 60 டிகிரிக்கு வந்து கனெக்ஷன்ல இருக்கும். Like that we are getting 6 pair. Totally we are getting 6 pulses. மொத்தமா 6 pulses னா நமக்கு வேணும் T3, T4, T5 will give you one more pulse. T5, T6 will give you one more pulse. Such that we are getting 6 pulses. 1 2 3 4 1 2 3 4 5 தான் இருக்கா. T6 T1 T6 T1 T1 T2 T2 T3. I forgot to consider T3 T4, right? நீங்களே போடுங்க. இங்க ஒரு 60. So totally we are considering 6 pairs. But what is the period of one thyristor? If you estimate, see that first in the 60 degree thyristor T1 conduction la irukka. Next 60 degree thyristor T1 will be in conduction. Like that, each and every thyristors are individually conduct for 120 degree. Right? அப்ப thyristor T1 மட்டும் நீங்க எடுத்துட்டீங்கன்னா see that upper leg க்கு நான் waveform பண்றேன். Upper leg, see that phase A க்கு upper leg thyristor T1 will lies in the upper leg such that it will carry positive current because it will carry positive voltage, positive current. These two people, that is T4 will carry negative voltage, negative current. I am given proof. அப்ப thyristor T1 க்கு நீங்க waveform வரையறீங்க அப்படினா you can start. For an example, omega t = 30 ல நீங்க thyristor T1 ஐ ட்ரிகர் பண்ணீங்கன்னா from 30 it will continue its conduction up to 150 degree because its conduction period is how much? 120 degree. It will continue its conduction for 120 degree. Right? This is current, that is your output current. We are going to get continuous current now, right? So thyristor T1 will carry this output current from 30 to 150 degree and then some other will come and take the charge. And thyristor T1 it will be turned off. Exactly at 150 degree thyristor T1 will turn off. That is the maximum period. Clear? And then what will happen? So over a period from 0 to 2 pi, from 0 to 2 pi, if I consider a single thyristor, ஒரே ஒரு thyristor மட்டும் நீங்க கன்சிடர் பண்றீங்க அப்படினா one thyristor will conduct only for 120 degree. Either you can consider thyristor T1 or T2 or T3 or T4. You can, that's your wish, right? So, but the conclusion is what? One thyristor will continue its conduction only for 120 degree. Whereas output current is continuous. There is no mistakes. Output current is continuous, right? So, let me draw the output current also, right? Say output current is continuous. But who is carrying that output current? That is the question mark here, right? Who will be carrying that output current? With respect to omega t, if I draw the waveform of output current, you will have a constant current. Output current is continuous. But in between 30 and 150, thyristor T1 will carry this output current. Clear? Anyway, I said in the same way, I would like to draw the waveform of source also, source current. Let us draw the thyristor current, right? So let me call this thyristor current. I think இங்க உங்களுக்கு தெரியாதுன்னு நினைக்கிறேன். நான் ஃபர்ஸ்ட் thyristor முடிச்சிடலாமா, அதுக்கப்புறம் நான் source current பத்தி பேசணும். I will zoom ஆகிடலாம். ஃபர்ஸ்ட் இப்போ thyristor முடிச்சிடலாம். Calculate the average value of thyristor current. If you want to know the value of average value, we have to estimate area by time period. Area by time period. Whereas the overall time period is 2 pi, right? Over a cycle. It is the period of the cycle. இப்போ நீங்க 2 pi வரைக்கும் அப்சர்வ் பண்ணீங்க அப்படினா 360 ல this is the one and only portion where thyristor T1 will be in conduction. அதுக்கப்புறம் 2 pi க்கு அப்புறம் you can observe the same cycle. Again 4 pi க்கு அப்புறம் you can observe. So each and every 360 this is the waveform. So period of a complete cycle is 2 pi. Out of this 2 pi from 0 to 30 it will be 0, from 250 to 2 pi it will be 0, from 30 to 150 it will have I naught. So one complete cycle period is 2 pi. Thyristor oda ஒரு complete cycle வந்து 2 pi தான், right? I am repeating once again. Actually நம்ம ஏன் 2 pi வரைக்கும் எடுக்கிறோம் அப்படினா first see இதோட waveform இப்படி தான் இருக்கும். அதுக்கப்புறம் 2 pi க்கு அப்புறம் பாத்தீங்கன்னா திரும்ப அதோட waveform இப்படி வரும். திரும்ப 4 pi க்கு அப்புறம் same waveform. So periodicity எப்படி செக் பண்ணுவீங்க? Periodicity in the sense we have to consider நீங்க waveform observe பண்ணனும். ஒரு particular time period க்கு அப்புறம் அதே after a particular time period same waveform has to be repeated. See there 2 pi க்கு அப்புறம் இதே waveform திரும்ப repeat ஆகுது. So you have to consider one complete cycle is 2 pi. அதுல நமக்கு வேல்யூ என்ன வந்திருக்கு? Only in this period. இதோட duration எவ்வளவு? This duration is, let me write it. Wait a minute, let me write all these things. 2 pi க்கு வேல்யூ நான் டிகிரில எழுதுறேன். 2 pi in degree calculated as 360 degree. Out of 360 degree, thyristor T1 will conduct only for 120 degree. 30 to 150 duration is 120 with the value of I naught. We know how to calculate. Here we have a rectangular. What is the area? Formula. Width into height. Width is 120, height is I naught. Such that if I cancel it, it is become 3. What is the conclusion? So the average value of the thyristor current is known as simply I naught by 3. Please should try to keep this simple things into your brain, because you will be tested for some worthless one mark questions in your examination. Output current of the 3-phase full wave rectifier is given as 90 ampere. What is the average current carried by the thyristor? Might be wondering, they will use some blah 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 data. There was a 3-phase fully rectifier, it is carrying 6 switches are there, each and every switches will conduct only for 120 degree. Like that, they will develop some story. Why? Because then only you will lift the, you will keep, that is what I can say, you will skip the question. They have to let you, right? You skip பண்ண வைக்கலாம் உங்க வேலையா இருக்கு. They will develop a big theory. But finally they will simply ask you, find the average current of the thyristor. அதுக்குள்ள என்னன்னா அந்த big storyக்குள்ள நடுவுல ஏதோ ரெண்டு சென்டென்ஸ் கொடுத்திருப்பாங்க. The output current is 90 ampere அப்படினு சொல்லிட்டு. What will be the answer? That 90 divided by 3 is your answer. Is the big story should be required? Yes, that is required for them, not for us. So should try to keep, if you find any big questions, you immediately have to think. If that questions will be tested your brain, right? You have to உங்களை skip பண்ண வைக்கிறதுக்காக அந்த question அப்படி கொடுக்கறாங்கறது நமக்கு தெரியணும். You have to take that question, you have to proceed. அங்க தான் ஒரு ஈஸியா ஆன்சர் வரும். Immediately you get the answer, right? Anyway, take this one. Similarly, if you are estimating the value of RMS value of the thyristor average current, right? Sorry, RMS value of the thyristor current, right? Let us estimate. Average value of the thyristor current is what? Thyristor, sorry, RMS current, not average. Very simple. நான் எப்படி சொல்றேன் இல்லையா? RMS value வேணும் அப்படினா same time period, but இது கூட நீங்க magnitude என்ன பண்ணிக்கணும்? Square your height multiplied by width divided by total time period. Should try to keep them all under root. அவ்வளவுதான். Magnitude மட்டும் ஸ்கொயர் பண்ணிட்டு அதே டைம் பீரியட், அதே ஹோல் டைம் பீரியட், but should keep them all under root such that I naught வெளியில வந்துரும். இத கேன்சல் பண்ணீங்கன்னா it will become root 3 because it is lying under root. See there? So RMS value of the thyristor becomes simply output current by root 3. Very important formula. might be looking chilly, but அவங்க கொடுக்குற கொஸ்டினை ரீட் பண்ணும்போது இந்த திங்ஸ் மறந்து போயிடும். So should try to understand. மறந்தாலும் ப்ராப்ளம் கிடையாது. We know how to develop. Clear? Yes. So this is thyristor. Now I would like to talk about source current, right? That's why I took one source. Totally we have three sources here. Phase A will be there, phase B will be there, phase C will be there. இப்போ ஒவ்வொரு சோர்ஸும் வந்து எவ்வளவு RMS current வந்து ரிலேட் பண்ணுது. Average value of the source current, we have to estimate the RMS value of the source current. Let us see from the output. Okay, for that, let me rub the thyristor current. Let us draw the waveform for source current. One second. Okay. Source current amount. I mean, we have three sources. No? I said phase A, phase B will be there, phase C will be there. எல்லாத்தையுமே எடுத்து வரைய முடியாது because all are identical to each other. Consider phase A. Let A multiply theta. This is phase A waveform. Phase A positive current will flow through thyristor T1. Negative current will flow through thyristor T4. But thyristor T1 எவ்வளவு conduction இருக்கும். For example, if thyristor T1 will start its conduction at 30 degree, then your source current will start flowing. Leg A ல thyristor T1 எப்ப டர்ன் ஆன் ஆகுதோ அப்பதான் என்ன ஆகும், இந்த source current will start flowing through it, right? Such that source current will enter at 30 degree, it will continuous up to next to 120 degree என்ன ஆகும், that is up to 150. Source current will flow. That is output current or source current, both are equal because input ல இருந்து output current போகுது. But the problem is what? In the period, thyristor T1 will carry the current from phase A for the output, right? And then what will happen? Next thyristor. We all know thyristor T4 எப்பங்க டர்ன் ஆன் ஆகும்? செக் பண்ணிடலாமா? நாம என்ன சீக்வென்ஸ் பார்த்தோம்? T6 T1 and then T1 T2 and then T2 T3 and then T3 T4 and then T4 T5 and then T5 T6. Anyway, I am in need of T4. இப்போ first example, நம்ம எங்க ஸ்டார்ட் பண்ணோம்? Our journey is started at 30 degree. T1 had been triggered at 30 degree, right? After 60 degree, we are triggering thyristor T2, that is 90 degree. After 60 degree, at 150, at 150 we are triggering thyristor T3. After ingerது 60, at 210 we are triggering thyristor T4. And then after 60, at what I can suggest 270 we are triggering thyristor T5. Anyway, it does not matter. So the conclusion is what? In the thyristor T4 எந்த இடத்துல trigger ஆகுது, it is started its journey, right? So 220 ல இது ஸ்டார்ட் ஆயிட்டு T5 அதே மாதிரி இந்த continuous conduction இருக்கும் 220 to 270 and then from 272 அடுத்து எங்க வரும், இந்த பாயிண்ட் வரைக்கும், ரைட்? அடுத்து நீங்க 330 தான் இத ஸ்டார்ட் பண்ணுவீங்க. So but T4 எதுல, இந்த இடத்துல இந்த 60 டிகிரி T4 ஆன்ல தான் இருக்கும், இந்த 60 டிகிரி T4 ஆன்ல தான் இருக்கும், ரைட்? See there 260 டிகிரி. ஆனா இங்க இருந்து இங்க it is started with journey 210 ல ஸ்டார்ட் ஆயிட்டு next 120 டிகிரி இது கண்டினியூ ஆகும், ரைட்? 210 plus 120 will become 330, right? So for the next 120 degree thyristor T4 will carry the current, right? So let us start our journey from 210 onwards, but negative current we have to draw negatively. Up to 330 we are carrying minus sign. Source side we have positive negative current only. From source side we have positive current, negative current. But load varumbodhu we know the way that we are designing the switching sequence will bring the output current as always possible, right? But input side we have negative current. See there, we are not getting purely sinusoidal current, we are getting what? Some discontinuous source current. Phase A ல இருக்க current வந்து we might think sir நம்ம sinusoidal தான் இன்ஜெக்ட் பண்ணோம். ஆமாங்க, sinusoidal தான் இன்ஜெக்ட் பண்ணோம். ஆனா நீங்க எங்க இருக்கீங்க? பவர் எலக்ட்ரானிக் switch. Over time நீங்க switching sequence கொடுக்கும்போது power electronic switches will inject the harmonics and it will create the discontinuities, right? So the thing is what? Source current will exist only for this duration. Now let us estimate the average value of the source current. Can anyone find the average value? What will be the average current? Positive area should be equal to what? Negative area. What is the average current? 0. So keep the very important key point. Many of you are making blunder mistakes. I think just 2 years ago there was a question in IES, I think, right? I have seen the question paper. I don't remember exactly which exam that was, right? Simply it was being tested. They had given a big story with a diagram, everything they had given. Diagram also they had given, right? Even me too. When I was looking at the question, I had a fear because I did not understood. They had given blah 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 things. Finally, after completely, I attempted the question at last only, but they had given 2 months for that question, for the worthless question. After giving big theory, find out the actually the question was indirectly they are asking find out the average value, average current delivered by the source. What is the average current delivered by the source? Your simple answer is 0. But because of the big diagram and story, I had a, what I can say fear. I was unable to touch that question because I did not read the question. I just read it. Sorry. I just left the question, right? So what I would conclude here, just to remember, that's why I am telling you the story. The thing is, average current delivered by the three-phase full wave rectifier from the source side will be 0. That's all. Because see there, area of the positive will be equal to area of the negative, such that it will become 0, right? Average current only 0, not RMS current. Why RMS current not equal to 0? Let us see. Average current 0, why? Because positive area equal to negative area, such that average value of the source current will always be 0, right? So source average equal to 0. Let us estimate source RMS. We all know, if you want to know the value of RMS current, what is the formula? RMS current வேணும் அப்படினா நான் என்ன சொல்றேன் I0 வந்து நம்ம ஸ்கொயர் பண்ணனும். Usually while calculating a rectangular value இருக்கு. இதுக்கு நீங்க RMS value calculate பண்ணனும் அப்படினா what I can told you, height ஸ்கொயர் பண்ணுங்க. அதுக்கு அப்புறம் இதோட corresponding width ஆல இத மல்டிப்ளை பண்ணிட்டு divided by the total time period. Anyway our total time period will be 360, right? அப்ப இங்க என்ன நடக்கும்? செக் பண்ணிடலாமா? கவனிங்க. Total time period வந்து 360 தான். ஆனா இந்த 360 ல from 30 to 150, this is 120 degree. In the 120 degree we have I0, அது ஸ்கொயர் பண்ணினா I0 ஸ்கொயரா மாறும் into 120 plus அடுத்தது from 210 to 330, அதுவும் 120 degree தான் duration, இதுவும் 120 தான். அங்க என்ன இருக்குங்க minus I0 இருக்கு. So what? நீங்க ஸ்கொயர் தான பண்ண போறீங்க. minus I0 whole square will become plus I0 square only-னா. So RMS current will be 0. Right? So into 120. And then I said keep them all under root. So I0 square into 120 plus I0 square into 120 will become 2 times of I0 square into 120. So twice of I0 square into 120 upon 360. Let us cancel now. It is 3. But all are lies under root. Finally what we have understood, RMS current will become, right? Source RMS current. Very important point now that I am writing now, because many times we were tested in this expression 2 by 3 times of root into I0. This is the expression for RMS value of source current. Don't forget, please, I am giving my sincere request. But average current is 0. Don't forget this key point also. If you forget, then you should try to learn how to draw the waveform. At least you have to remember the procedure, right? It should be required, right? Because in the examinations will be tested for worthless question. I'm repeating, right? Now, as of now, it is looking like a chilly one. But later you have to remember, that is very important. From the power electronics, you have to remember the concepts. Questions are always very easy. You can crack it easily, right? That's all. So this is all about three-phase, what I can say, fully rectifier. Now here, I would like to conclude one more small thing, right? And I am requesting all, please in your free time, investigate. Till now we saw how to express, that is how to calculate the circuit turn-off time, right? Anyway, I will give you, I don't want to do this here, but we know how to calculate the circuit turn-off time. We had been habituated, right? I am giving small investigation. Take this waveform in your free time, calculate the circuit turn-off time for two things. One is for discontinuous connection and one is for continuous connection, right? Discontinuous connection, sorry, for the continuous connection, alpha is less than 60, right? In that case, wait a minute. Let us estimate the LF circuit turn-off time, right? It can be written as 240 minus alpha by omega, right? Yes. Next, if the value of alpha will become greater than 60, then the circuit turn-off time will become that is 180 minus alpha only. That is correct. That's all. So this is the formula to obtain the value of circuit turn-on time. Please investigate. That's not a big deal because we have been habituated. Very simple thing. Waveform எடுத்துட்டு the value எடுத்து பார்த்துக்கோங்க. That's all. It is 240. Yes, that is correct. That is the formula to obtain the value of what I can suggest circuit turn-on time. At the same time, time is the conduction period, right? Conduction period of the thyristor. You can also estimate that one. That's very simple. We know that things are being anyway. Thyristor conduction period. நம்ம என்ன பார்த்தோம்? Case number 1, right? Case number 1, when the value of alpha is less than 60, then what is the conduction period of the thyristor? 120 degree. If the value of alpha is greater than 60, then what will be the period, conduction period of the thyristor? Alpha value நீங்க greater than 60 வந்து raise பண்ணீங்க அப்படினா, right? Minimum the thyristor will be triggered at alpha equal to what I can say 6 alpha plus 30 degree the thyristor will be triggered here. And it will be continuous. That is, I am talking about discontinuous conduction. It will be continuous its conduction up to what? Only 150 degree. Clear? So its period is what? If I trigger the alpha, for example, listen. If I trigger the value of alpha, alpha is going to be discontinuous conduction in the sense it is above 60. For 90 degree, when you trigger it will conduction. Its conduction period is what? 90 plus 30 will become what I can say 120. In between 120 and 150 only you can observe the conduction period. You can observe the conduction of the thyristor period. So you can observe the conduction of the thyristor, right? So the conclusion is what? When I am looking for the thyristor, right? So anyway, your thyristor will be end of the time the conduction will come two things, right? That is continuous strain. But T6 மட்டும் எடுத்துக்கிட்டீங்க அப்படினா two parallel இருக்கும், right? First 60 degree thyristor conduction நீங்க பார்க்கலாம், and in the next 60 degree also you can observe the conduction period of the thyristor. Right? Like that, if I select the first thyristor, it will going to produce its conduction from what? Alpha plus 30 to 150. Second thyristor, I mean, if T1 மட்டும் எடுத்துக்கிட்டீங்கன்னு வெச்சுக்கோங்க. T1 வந்து நீங்க கரெக்ட்டா alpha plus 30 க்கு ட்ரிகர் பண்ணீங்க, it will continue its conduction up to 150. Next, in between 150 and 180 it will be 0. Conduction இருக்காது, discontinuity வந்துரும். Through after 180 you can observe, right? 90 degree ட்ரிகர் பண்ணீங்கன்னா first thyristor வந்து 90 degree ட்ரிகர் ஆகுது அப்படினா that is second thyristor will be triggered after 60 degree, right? அப்பனா 150 ல அடுத்த thyristor வந்து trigger ஆகும், right? அப்ப அந்த டைம்ல என்ன ஆகும்? There will be thyristor T1 will continue its conduction. From T6 T1 you can observe the thyristor conduction period. Again from T1 to T1 also, T1 to T2 also thyristor T1 will be in conduction. Giving small work, find out the conduction period of the thyristor in this zone now, right? அப்ப இதுல conduction கண்டுபிடிங்க, இதுல conduction. I have drawn the waveform, right? If you just notes revise பண்ணிட்டு அங்க conduction period of the thyristor எவ்வளவு இருக்குன்னு பாருங்க. Just consider any one thyristor. Don't take all the people. Consider any one thyristor and the one thyristor எவ்வளவு நேரம் conduction இருக்குன்னு மட்டும் பாத்துக்கோங்க. That's all. Just to keep your answer here. I'm dropping some small things. At last I will tablet column correct பண்ணிக்கோங்க நீங்க. That's all. Okay. So this is all about three phase full wave rectifiers. It's over, right? Next, I had given a small work. I think day before yesterday, I did not remember exactly. I had given a circuit. ஒரே ஒரு thyristor plus I had given 3 diodes, right? I am really very happy. Only one person, I don't know who is that one. I have tried that one and posted in the group. I have seen the answer, but that answer is wrong. Your way of approaching is correct, but did you notice? And the circuit another careful observe பண்ணுங்க. I don't know how many of you done that one. I said once upon a time you were tested with some. See nowadays your questions are very easy from power electronics. If you notice, நீங்க எந்த எக்ஸாம் எழுதுனாலும் சரி லாஸ்ட் ஒரு 5 இயர்ஸ் क्वेश्चंस பேப்பர் எடுத்து பாத்தீங்கன்னா क्वेश्चंस வந்து ரொம்ப ஈஸியா இருக்கும். But the thing is எடுத்துக்கிற क्वेश्चंस எல்லாமே லாஜிக்கலா இருக்கும். Logical in the sense they are not taking the questions just by using the blah blah things that you are studying on the book. Questions they are taking whether the things you understand or not. இப்போ 3 phase circuit ஓட ஆபரேஷன்ஸ் ஃபுல்லா புரிஞ்சதுக்கு அப்புறம் இது உங்களுக்கு தெளிவா புரிஞ்சிருந்ததுனா you can attempt that question. Just by remembering this formula you cannot crack the question. Like that they are taking the question. But questions will be very very easy if you remember the logics. That's why I have given that question, right? Actually that is not the standard circuit. Every one of us knows. But what I have been told, anyway, let me draw this circuit. I take full wave rectifier, right? I think. But what I have done, one controlled switch, 3 uncontrolled switches. I said connect resistive load, right? I do remember. So this is going to be our supply, that is Vm sin omega t. Can you please draw the waveform now? Thyristor T1, diode D3, D2, D4. Here we have a load. That thing's in, right? So this is the point where I am going to observe the output voltage, and this is the point where we are going to receive the output current, right? Let us draw the waveform. Listen, from the input side we have to consider two types of circuit. Yes or no? This is thyristor T1, diode D2 will going to take responsibility for positive cycle, whereas in the opposite case D3 and D4 will going to take responsibility for second thing, D3 and D4. Yes, this is the second one, right? Let us run this one. Yeah, let us consider this. Now, if you want to draw the output waveform, how will you draw? It's simple logic, right? But slowly understand. We have to try it. That's all. Chilly mistake. Actually, everything is correct. First half cycle, first we are injecting positive here, negative here. Positive half cycle. This positive will become here. So opposite automatically will become negative. This positive will become negative plus here automatically going to be negative. See there, another leg will going to carry negative voltage. So if it is negative, opposite is going to be positive, here negative. If it is negative, opposite is going to be positive. We know that things, right? Now, which diode will turn on? See that this diode will immediately turn on because anode voltage greater than cathode voltage. Can you turn on this diode? No. Can you turn on this diode? No. What about this thyristor? This thyristor, one condition is satisfied, but another one is I have to, until the arrival of gate pulse, I cannot turn on this thyristor. But now it is in forward blocking mode. Do you agree? Yes. So, forward blocking mode, when the moment you are triggering the thyristor, immediately it will turn on, such that your input is being reflected in the output side. Happily, I have seen that answer. This is correct. You have drawn this one. This is exactly correct. But you have left the second portion. What happened in the second circuit? When we are going from omega t to 2 pi, that is from pi to 2 pi. In the second half cycle, did you notice? See there, in the second half cycle, I said we have resistive type of load. And though we have inductive type of load, what will happen? Okay, you don't need to be worried about the type of the load. You can consider resistive load, inductive load, whatever, right? Let me write general. In general, you don't need to consider resistive load also. In general, let's see what happened. What load? See, second case, first case, this is the waveform. Second case, in general. Rub that resistive load, let me draw it generally because load just notice this one. After pi, second half cycle, the polarity of the supply is reversed here. It will become minus, it will become plus. Such that immediately let's see what happened, right? Generally I am drawing. We don't need to talk about whether it is resistive load or RL load, RE load. I don't want to know anything, nothing, right? I am just drawing the general waveform. After pi, what will happen? Polarity of the supply will be reversed. So immediately this thyristor commonly, right? See, sorry, it is minus now, right? Sorry, it is plus. So if it is minus, opposite is going to be plus. Similarly, plus is being injected here. It is plus, it is minus. If it is plus, it is minus. Immediately this diode will be turned off. Why? After reversing the polarity of the supply, here we are getting negative. Here we are just observe these things from the supply. So it will be turned off. What about this one? Positive anode, negative cathode. This diode will turn on. Positive anode, negative. This diode will turn on. What about this thyristor? It will be turned off. Do these things from the supply, right? So after pi, in general I am drawing. I am not observing any type of load. I am looking these things from the source. So the thing is, what will happen after pi immediately, right? So irrespective of the load setup, if the supply is being reversed, then diode D3 and D4 will turn on. Do you require any gate triggering pulse for this? No. If it will turn on, then what will happen? See there, this is the positive. If the supply it will come here, it will go. Which diode will turn on? This diode will turn on, right? So immediately it will turn back. It will travel through this diode. It will reach the output and is getting back. Again, it is getting back through diode D4. Cycle is being completed. What is wrong with this? Is there any mistake in my conclusion? Do I want to turn on? Do I need any triggering pulse? No. அப்ப என்ன நடக்கும்? Simply these two diodes will be short circuit. Input will be simply reflected across the output such that if you draw the waveform further, it will become like this. You will get the sinusoidal cycle. You are going to get sinusoidal cycle, right? Now, if you find the இப்போ நீங்க estimate பண்ணுங்க. Value வந்து போட்டீங்கன்னா you get the answer. Clear? Now same cycle is being repeated often. Now see there. What is the period of one cycle? You cannot say period of the cycle is only pi, sir. Why? Is it pi? பாருங்க உங்களோட ஆன்சர் வந்து பையா இருந்தது அப்படினா I said that is wrong. Why that is wrong? நீங்க பை சொன்னீங்கன்னா 0 ல இருந்து பை குள்ள உங்களுக்கு வேவ் ஃபார்ம் எப்படி வந்திருக்கோ அதே மாதிரி வேவ் ஃபார்ம் தான் பை டு 2 பை குள்ள வந்திருக்கும். Are we getting same type of waveform? No. So the period of the cycle is 2 pi. First thing. Why it is 2 pi? After 2 pi you are getting the same cycle. One discontinuous, one continuous waveform. After 2 pi. So from 2 pi to 4 pi it will be repeated. From 4 pi to 6 pi it will be repeated. So the period of the cycle is 2 pi. It is not pi. First thing that is wrong. Right? Some of you going up with the pi, that is wrong. Just to remove that thought from your mind. Second thing. From alpha to pi we have some sinusoidal omega, that is Vm sin omega t. Did you notice? From pi to 2 pi we are getting minus Vm sin omega t. We are not getting plus Vm sin omega t. Then the minus Vm sin omega t. See there, sin omega t இருந்தா என்ன நடக்கும் அப்படினா from pi to 2 pi you are getting this waveform. Yes or no? Sin omega t அப்படினா மீனிங் என்னன்னா we are getting this one. Sin omega t pi to 2 pi க்கு நடுவுல நெகட்டிவ்ல போகும். அதுக்கு நீங்க மைனஸ் எடுத்தீங்கன்னா என்ன வரும்? Vm sin omega t க்கு நீங்க minus Vm sin omega t போட்டீங்கன்னா we are tilting the waveform very here. Clear? Let us estimate. Now calculate the V naught average. I said just to calculate the V naught average, right? Let's see what happens. Sorry. Yeah. So V naught average is going to be area by time. Total time it is 2 pi. Let us estimate. Let us go from alpha to pi. I am considering Vm sin omega t with respect to d omega t plus pi to 2 pi. I am requesting on, let us see. Now minus Vm sin omega t போட்டா என்ன வருதுன்னு பார்க்கலாம், right? And then you will understand. Reduce பண்ணி we are getting 1 by 2 pi. Anyway, Vm is common. எல்லா இடத்துலயுமே Vm common தான். I can take it out. First cos omega t reduce பண்ணீங்கன்னா minus cos omega t. Limits are going from alpha to pi plus இங்க நீங்க reduce பண்ணீங்கன்னா already we have minus, sin integrate பண்ணீங்கன்னா 1 more minus such that it will become plus cos omega t. Limits are going from 2 pi to pi. So your answer is going to be Vm by 2 pi. Upper limit cos pi minus 1. Already we have 1 more minus such that it will become plus 1. Lower limit will become 1 plus cos alpha plus this one cos 2 pi 1 minus of cos pi. Cos pi will give you 1 minus 1. In the integral limit we will have 1 more minus such that we will have plus 1. What is the total value? 1 plus 1 2, 2 plus 1 3. So the answer is Vm by 2 pi into 3 plus cos alpha is the correct answer. Clear? That is the correct answer for C. That is what I told you. You got to understand. Don't memorize anything. இப்போ இந்த மாதிரி ஜெனரல் சர்க்யூட் கொடுத்தா நீங்க எப்படி வரைவீங்க உங்களுக்கு தெரியணும். அதே மாதிரி y am putting minus Vm sin omega t. I am repeating once again. In the second pulse we have the opposite. இப்போ பாருங்க ஆல்பா ல இருந்து பை வரைக்கும் சைனூசாய்டல் சிக்னல் தான் போயிருக்கு. So I took Vm sin omega t. அதுக்கு அப்புறம் பாத்தீங்கன்னா ஒரு கம்ப்ளீட் சைக்கிள் நீங்க செலக்ட் பண்ணிருக்கீங்க. இப்போ நீங்க 0 to pi மட்டும் செலக்ட் பண்ணீங்கன்னா நம்ம Vm sin omega t அப்படி எடுத்துக்கலாம். நமக்கு என்ன தெரியும்? 0 ல இருந்து 2 pi வரைக்கும் நம்ம கன்சிடர் பண்ற சைக்கிள் Vm sin omega t தான். அப்ப Vm sin omega t ஓட வேவ் ஃபார்ம் எப்படி இருக்குன்னா இப்படி இருக்கும். ஆனா பைக்கு அப்புறம் என்ன இருக்குன்னா ஆப்போசிட்ல வந்திருக்கு. So that's why I'm putting minus Vm sin omega t. Understand this is logically you should think. சார் அப்ப எங்கெல்லாம் வந்து மேல வருது அங்கெல்லாம் மைனஸ் பண்ணுமா? Not like that. அப்படி நான் சொல்லவே கிடையாது. நான் சொல்றது நான் எடுத்துட்டது டோட்டல் சைக்கிள். நீங்க பீரியட் எவ்வளவு எடுத்துறீங்க? 2 pi எடுத்துறீங்க. ஒரு கம்ப்ளீட் சைக்கிள்ல நீங்க sin omega t சூஸ் பண்ணும்போது this is your original waveform. But I am not getting that one. Opposite line வந்திருக்கு. Suppose என்னோட பீரியட் வந்து only 0 to pi மட்டும் நான் செலக்ட் பண்ணிருக்கேன் அப்படினா I am very happily we can go with the Vm sin omega t. But நான் செலக்ட் பண்ண சைக்கிள்ல சைனூசாய்டோட நேச்சர் இது கிடையாது. but I am getting this one, that's why I am putting minus. Clear? Okay. So we are getting 3 cos alpha. This is the correct answer. Clear? Just to make a note of it. Once upon a time you are tested. Now ஒரு question bank post பண்ணிருக்கல, அந்த question bankல அந்த question இருக்கும்னு நினைக்கிறேன். நீங்க செக் பண்ணி பாருங்க, right? Just you can go with this answer, you will get the answer. Okay. And the next thing, we have to do one more small topic is in bending, that is called harmonic analysis. Harmonic na we should estimate the value of distortion factor, fundamental displacement factor, input power factor. We know anyway. Let me recapture all those things, and we should see the relations between them, and we have to estimate the value of total harmonic distortion. For that it may take some half an hour, but I am requesting all, tomorrow I will do that one, because I am letting you all to collect the voltages, like voltage in the sense V0 average, I0 average, I0 RMS, V0 RMS. இதெல்லாம் வந்து நம்ம முன்னாடி கால்குலேட் பண்ணிருக்கோம் ஒவ்வொரு சர்க்யூட்க்கும். அதுக்கெல்லாம் நீங்க ஒரு ஷார்ட் நோட்ஸ் ப்ரிப்பேர் பண்ணுங்க. அதர்வைஸ் நீங்க ப்ரிப்பேர் பண்ணுங்க. I will post one PDF file நான் ரெடி பண்ணி போறேன். I have some notes, some short notes I took earlier. That notes still I am having with me. I will post that notes. I may left some formula when I was preparing. If I நான் ஏதாச்சும் formulas நல்லா ஞாபகம் இருக்கு, எனக்கு ப்ராசஸ் தெளிவா தெரியும் அப்படினா அந்த formulas நான் எழுதி வைக்க மாட்டேன், right? Because that I took that notes just I think ரொம்ப நாளைக்கு முன்னாடி எடுத்த notes, right? So அதனால இருக்க notes just you can follow it, right? அதுல ஏதாச்சும் மிஸ் ஆயிருந்தது அப்படினா you can make a note of it. நீங்க அத ஜெராக்ஸ் எடுத்துட்டு அத நீங்க எழுதி வச்சுக்கோங்க. Clear? That's all. Entire power electronics cycle. Okay, let me run this one. So my suggestion is tomorrow I will solve, we will take that chapter, but before proceeding that things, blah blah things முன்னாடி நம்ம பார்த்த ஃபார்முலா சப்ஸ்டிட்யூட் பண்ணி ஆன்சர் போடணும், அவ்வளவுதான். அது புதுசா நான் டெரைவ் பண்ண போறதுல புதுசா பார்க்க போற மாதிரி மைண்ட்ல திங்க் பண்ணாதீங்க, ரிவைஸ் பண்ண போறோம், அவ்வளவுதான். பட் அந்த ஃபார்முலாஸ்லாம் உங்களுக்கு ஞாபகம் இருந்தா தான் I can proceed, right? That's why I am ready you all to revise all those things, correct those things and put it separate of short notes போட்டு வச்சுக்கோங்க. Today evening I will post, okay, in the group I will send that PDF file. You can just follow it, you can keep it, make it xerox if it is possible. And one more thing, and apart from that there is one more small thing, that is called I forgot to take one more chapter. நம்ம சாப்டர் கிடையாது, இந்த மிட் பாயிண்ட் ரெக்டிஃபயர் ஒரு இருக்கு இல்லையா, தட் இஸ் ஃபுல் பிரிட்ஜ் ரெக்டிஃபயரை பற்றி பார்த்துட்டு இருக்கும்போது மிட் பாயிண்ட் ரெக்டிஃபயர்னா சென்டர் டேப்லர் ரெக்டிஃபயரை பற்றி நான் பேசுகிறேன்னு சொல்லியிருந்தேன், பட் ஐ டிட் நாட், ரைட்? ஐ ஃபர்கெட் அண்ட் டைரக்ட்லி ஐ switched to 3-phase rectifier, right? So actually we are not using that one, but we have to understand that operation wise whichever the things that we saw, the full bridge rectifier la enna pathamo same operation, nothing is going to be different, ellame same da, but the one only difference is peak inverse voltage. Peak inverse voltage வச்சு பார்த்தோம் அப்படின்னா the maximum peak inverse voltage offered by the normal full bridge rectifier is Vm, அவ்வளவுதான். நம்ம கால்குலேட் பண்ணது Vm இருக்கலாம் இல்ல Vm plus E based on the loads. ஆனா இந்த bridge rectifier ல மட்டும் சரி, when you are taking center tablet, mid point center tablet rectifier எடுத்தீங்க அப்படின்னா அதுல மட்டும் நமக்கு என்ன கிடைக்கும் அப்படின்னா twice of peak voltage கிடைக்கும். Maximum peak voltage will become, right? So the voltage drop across the thyristor will become twice of the maximum voltage. That is the one and only difference between the present one, that is midpoint rectifier and the bridge rectifier. Remaining operations and discussions, everything will be remains same, nothing is going to be different. Anyway, just I will show the peak inverse voltage only, because operations at all you can do the all performance, whichever things that is in full bridge rectifier, same thing you can consider. So let me take this circuit first, that is center tapped rectifier, midpoint center tapped rectifier. Let us draw this circuit first. In the primary side we are carrying a transformer, that is we are carrying a transformer here. Secondary also we are going to carry transformer only. Now let me explain. From the transformer we are going to collect the things. Let us see. Yeah, this is the transformer, right? So now let me join this one for understanding. Let me show it clearly. So this is the point where we are going to connect the load. This is the circuit. See here we have this is primary transformer, that is primary winding. The turns ratio between these two windings is 1:1. The turns ratio between these two also 1:1 only. It means in the primary side, if I am injecting plus Vm, let us take. Actually, let us continue our lecture with this. In the primary side, let us see what happened now. Let us take this supply. Let us connect it with this circuit. Now here I am going to inject Vm sin omega t from the input side. see, when we are discussing about in a positive cycle electrolyte, same positive cycle will be generated here, such that it will become plus or minus Vm, such that it will also will become plus or minus Vm, such that it will also will become plus or minus Vm. Clear? So we are designing the transformer such that either the polarity anamata we design it, right? In the dot lo the current enter agudina, see there in the dot lo the current leave out, right? So here we have the dot, right? So let us take this one, right? So here through this thyristor they are going to pass the current. But the problem is what happened here. If you have noticed these two thyristors carefully, anyway, these dots and all should not require. Don't think too much about these things. Just let me explain. Because with the dot I am not going to read it. See there, this positive is connected with the. If input வந்து நீங்க positive cycle கொடுத்தீங்க அப்படினா, here we have. இங்க என்ன polarity இருக்கோ same polarity, same voltage will be induced here also. And the first thing is positive of the supply will be connected with the anode automatically. அப்ப இங்க என்ன வந்துரும் negative. See there, negative of the supply will be connected with the anode, it will become positive. Can you turn on this thyristor? No, but this thyristor can be turned on while giving the positive supply. So அப்ப நீங்க positive supply கொடுத்துட்டீங்க அப்படினா என்ன ஆகும்? After நீங்க இந்த thyristor trigger பண்ண உடனே, for example case number 1, right, while going from alpha to pi in the positive half cycle, while going from alpha to pi, this thyristor will be short circuit. Why it will be turned on? Thyristor T1 will be turned on. Thyristor T1 will turn on. What about thyristor T2? It will be open circuit. Why? Because negative supply, it is reverse blocking voltage, right? That is called reverse blocking voltage. Now reverse blocking voltage is known as peak inverse voltage. I would like to know the maximum peak inverse voltage across the thyristor, right? Now let us estimate the peak inverse voltage or maximum. Now peak inverse voltage is the meaning is reverse blocking voltage, maximum reverse blocking voltage offered by the thyristor. If you see there, if this thyristor will be turned on, then what happens? The current is started flowing like this. It will come like this. It will come. It will come. It will coming back. Load like current entering point plus leaving point is minus. Output voltage should become equal to input voltage. So same Vm will be dropped across this one. Let us estimate. Now across this transformer, the induced voltage is minus plus Vm, right? Let us see. Apply KVL for this loop. If you want to know the value of peak inverse voltage, இப்போ இந்த லூப்க்கு நீங்க KVL அப்ளை பண்ணுங்க. I know this thyristor is turned off. இப்போ இந்த KVL அப்ளை பண்ணுங்க. I am starting from here minus Vm, here minus Vm, right? I am coming here. We are in reverse blocking voltage. அப்ப இங்க plus இருக்கு, இங்க minus இருக்கும். Such that we are getting peak inverse voltage is going to be peak inverse voltage. Let me define as peak inverse voltage equal to 0. Such that peak inverse voltage will become twice of Vm. See there. ஒரு thyristor ஆன்ல இருக்கும்போது இன்னொரு thyristor ஆஃப்ல இருக்கும். இதே கேसेस நீங்க செகண்ட் சைக்கிள்ல அங்க அப்சர்வ் பண்ணலாம், ரைட்? செகண்ட் திங், இந்த thyristor ஆன் ஆயிடும், இது ஆஃப் ஆயிடும், polarity எல்லாம் ரிவர்ஸ் ஆயிடும். அதே மாதிரி அங்க 2 Vm வரும். See that the peak inverse voltage of each thyristor is going to be twice of Vmax. That is the drawback of center tapped bridge. That's center tapped full wave rectifier. Center at the center point exactly with the equal number of tanks, we are breaking them into two half. With the help of transformer, we are designing the circuit. Whereas in the bridge circuit, do I need of any transformer? Of course, transformer will be there. Second side of the transformer will be there in the universe. We cannot talk about that one. I am not talking about that transformer. I am talking about on the transformer illama we are designing one more separate arrangement here. With a separate arrangement of the transformer, we are designing this rectifier circuit. So first thing is cost wise transformer, we all know if you want to design the transformer, we have to invest more amount of money. We have been played with already transformers, right? So I have to invest more amount of money. For second thing is I have to design these thyristors in order to what I have to do in order to get the blocking ability as twice of supply voltage. நீங்க supply voltage 220 voltage கொடுக்குறீங்க அப்படினா your thyristor rating, right, your thyristor will be designed for 440 voltage because twice of maximum voltage will going to be dropped across the thyristor. So the investment or the amount of manufacturing cost, right? So the manufacturing cost of the thyristor is increased, right? And the manufacturing cost of the circuit is increased. Whereas when I am talking about full bridge rectifier, simply there is no need of transformer at all. I need 4 thyristor with the same supply voltage, Vm, because peak inverse voltage across the thyristor will become only Vm, not twice of Vm. Conclusion is over. So the highest cost is simplistic here. That's the drawback all about these things here. This is the one only difference. Remaining you can இப்போ நீங்க என்ன பண்ணுவீங்க, பாசிட்டிவ் சைக்கிள்ல இந்த டைரஸ்ட் ஆன் ஆகுதுன்னா நெகட்டிவ் சைக்கிள்ல இந்த டைரஸ்ட் ஆன் ஆகும். Same operation. Whichever things that we have been seeing for bridge rectifier, you can see the same operations, R load, R load, whichever things are the same thing, right? So don't be panic. அப்ப இந்த மாதிரி டயகிராம் கொடுத்திருக்காங்க, இதுல வந்து R load R load கொடுத்துட்டு உங்களை ப்ரொசீட் பண்ண சொல்றாங்க அப்படின்னா, bridge rectifierல R loadக்கு நீங்க என்ன ஃபார்முலாஸ்லாம் பாத்தீங்கன்னா ரெகுலரா நீங்க போட்டுக்கலாம். எதுவுமே டிஃபரன்ஸ் இல்லை. R load R load எல்லாம் அப்படியே தான் வரும். ஒன் அண்ட் ஒன்லி டிஃபரன்ஸ் பீக் இன்வெர்ஸ் வோல்டேஜ். Clear? And the cost is very high, investment cost. That's why we are not giving priority for this one. That's why I took only bridge circuits. Clear? That's all. So it is three-phase controlled rectifiers with the control switches are completely over. But as I said, we can also do all these things with the help of uncontrolled diodes. That's why uncontrolled switches, they are simply called diodes. Designing the diodes is not a big deal for you all. I am repeating once again. இங்க ஒரே ஒரு டிஃபரன்ஸ் என்ன அப்படின்னா, டயோட்ஸ் பொறுத்த வரைக்கும் ஃபயரிங் ஆங்கிள் வந்து நமக்கு கொடுக்க தேவையில்லை. சப்ளை வோல்டேஜ் வந்தாலே ஆட்டோமேட்டிக்காக டர்ன் ஆன் ஆகிடும். ஸோ whichever things that we saw, இப்போ நம்ம முன்னாடி பார்த்த கேசஸ்லாம் வந்து ஃபயரிங் ஆங்கிள் எங்கெங்கெல்லாம் நீங்கள் பார்த்துருக்கீங்களோ, தட் இஸ் ஆல்ஃபா. ஆல்ஃபாவுக்கு நீங்கள் 0 போட்டிங்க அப்படின்னா that circuit will resembles the property of diode. Clear? Yes. So let us take some example. Tomorrow I will take some circuits, right, for your better understanding. I will take some circuits and I will demonstrate those things here, how diode is getting different from the circuit. If you are finding any new circuits, and my sincere suggestion, understand the circuit topology and understand how to analyze these things. Don't memorize anything, because in the power electronics nowadays your questions are being that is, you will be tested logically. So you are expecting direct questions also, you can expect. One thing is you have to use your brain. நீங்க learn பண்ணிக்கலாம், எப்படி பண்றதுங்கிறது கத்துக்கிட்டா தான் உங்களால முதல்ல கிராக் பண்ண முடியும். Anyway, I will demonstrate some circuits, not all circuits. Rest of things you can do it. Example நீங்க அந்த क्वेश्चन பார்த்த உடனே எப்படி டிரா பண்றதுன்னு, நீங்க ஒரு fully derivation கேக்குறாங்க அப்படினா ஒரு lengthy question கேக்குறாங்கன்னா at the end like easy questions எல்லாம் ஃபுல்லா சால்வ் பண்ணிட்டு லாஸ்டா நீங்க செப்பரேட்டா டெரைவ் பண்ணி just to bring the answer. Play it. Don't memorize. Repeating. Clear? That's all. Probably these things are over. Now we are not going to solve problems because almost we are touching 8:45. I had posted on question bank, right? So I am requesting all, please sit, rectifiers notes one time full revise பண்ணிட்டு should try to take all these things, should try to what I can say solve some problems. Tomorrow we will solve all the problems. Anyway, my responsibility, I have to show you how to crack the questions. So tomorrow I will solve all the questions and then we will start chapters. Hereafter things are going to be small. Rectifier is the slightly big chapter. All things are easy, you know, we have seen it. Lightly bigger than rest of chapters. They are very small. We will complete them soon. Okay. If you have any other doubts, you can ask in the group, right? So let me wind up. I don't know whether you people are traveling on the same track. Let's wind up. If you have any other doubts, please let me know in the group, right? Thank you all. Thank you. So